Welcome to JavaScript for Beginners. In this course, you're going to dive into the essentials of the most widely used programming language in the world. Designed with beginners in mind, this course is segmented into 7 comprehensive sections. After finishing this course, you'll have the skills needed to tackle advanced courses and move closer to a career in tech. Section 1. We begin by exploring what JavaScript is and why it's a great first programming language to learn. I'll then guide you through setting up your development environment and take the first steps into writing software. In Section 2, you'll learn about JavaScript variables, the fundamental building blocks of storing and structuring data. Section 3 introduces you to the symbols and operators essential for performing calculations, modifying data, and executing logical operations. Dive into the power of programming as we cover control flow. You'll learn how to direct your programs using loops and conditional statements, making your code more dynamic and interactive. Objects are crucial in object-oriented programming for creating modern applications. This section demystifies JavaScript objects and their role in developing applications. Learn about arrays, a pivotal data structure in JavaScript. We'll explore commonly used methods to manipulate and utilize arrays effectively. We'll wrap up with functions, enabling you to write clean, reusable code that can simplify complex tasks. Start your coding journey with JavaScript for Beginners on Stephen Codecraft. What is JavaScript? JavaScript stands as the most popular programming language in the world, essential for front-end web development. It powers the interactivity on websites, but its capabilities extend far beyond. JavaScript can also craft backend services, desktop apps, and even mobile applications. Let's break down a modern website. It's built using HTML, CSS, and JavaScript. HTML lays the foundation, structuring the web page. CSS steps in to style and design the structure, adding colors, layouts, and fonts. Then JavaScript brings it all to life. It makes websites interactive in real time, like when you like a post or scroll through a feed, all without reloading the page. A common misconception is that JavaScript and Java are related. In reality, they're very different languages and serve distinct purposes. Java often powers large enterprise backends, while JavaScript is the go-to for front-end development across all companies. This makes JavaScript an essential skill for web developers. The core programming principles you'll learn here aren't just limited to JavaScript. They're transferable to other languages too. Despite JavaScript's unique aspects, it's an excellent starting point for beginners. It's dynamic, powerful, yet easier to grasp compared to other, more verbose languages like C# or Java. By mastering JavaScript, you're not only learning an in-demand programming language, but also grasping the foundational coding concepts applicable across software development. To start programming JavaScript, there are 2 essential tools you'll need to install: Node.js and Visual Studio Code. So what is Node.js? This is a powerful runtime environment that lets you run JavaScript outside the confines of a web browser. It's what enables you to build and run JavaScript applications on your computer, including server-side projects. While you could just run JavaScript in your browser, for this course we will be using Node.js to execute our programs. The second tool is Visual Studio Code, otherwise known as VS Code. Developed by Microsoft, this is an integrated development environment, or IDE for short, and this is where you'll spend most of your time writing, testing, debugging, and running your code. It's a versatile desktop application used by developers worldwide, and we'll be using it throughout this course. Both Node.js and Visual Studio are free and easy to install. Installing Node.js. Begin by opening your browser and heading to nodejs.org. Once you're on the site, click to download Node.js. LTS stands for long-term support. Downloading this version is recommended for most users because it's the most stable and well-supported version of Node.js. Once downloaded, open the installer and follow the on-screen instructions. The default settings are suitable for most users, so you can proceed with them unless you have specific preferences. Installing Visual Studio Code. Next, we'll install our IDE. Navigate to code.visualstudio.com in your web browser. Click the download button for your operating system. VS Code is available for Windows, Mac, and Linux. After downloading, run the installer. Like with Node.js, the default installation options will work perfectly for our purposes. So now once you have installed both Node.js and Visual Studio Code, click to open up VS Code. After you click it, you will see the welcome page. Then open up Finder or File Explorer if you're in Windows, and create a new folder. Now this will be the folder where we place our code, so I'll just name it Project. Now, the name of the folder doesn't matter. Then I can click and drag it into VS Code. This will open up the project. Now to add a new file to our project, I can click on this icon, and I can name it code.js. So the name of this file doesn't matter, but the file extension does. So now we can write our first line of code, and I'll say console.log, then in single quotes, I'll say hello world, and then I'll end it with a semicolon. Notice as I'm typing, this file has not been saved yet, and so I see a circle indicating that I have unsaved changes. So to save it, I can do Command S, or on Windows it would be Control S. So now if I want to actually execute this file, I can do File, Appearance, and then Panel to open up the integrated terminal in VS Code. Now there's also a shortcut. I can do Control and backtick. So if you don't use the backtick character often, it's located on the left-hand side of your keyboard above the Tab key. So I can do Control and backtick to toggle this open. So I'll be using Node to execute this program. So I'll type Node, and then the name of our file, which is code.js. So here we see this value, hello world, is logged to the console. So I'll close this, Now, VS Code offers a lot of features and a lot of ways to customize it. Before this course, we'll just be covering the basics that you need to get started. So on the left-hand side is the activity bar, where we see a list of icons. The topmost icon is the folder icon, and we can use it to toggle our project to see the folders and files within it. Next is the search icon, and we can use this to search, find, and replace text. So for example, let's say if I do hello, and enter, we see that this text is found in our code.js file. So I'll close that. The next one is our source code icon, and this is used to keep track of the changes in our project, as well as collaborate with other developers using Git version control. Next is the run and debug icon. You would use this when setting breakpoints in your code and debugging it if there are errors. Next is the extensions icon. This gives you access to the extensions marketplace. So this enables you to install additional features to VS Code to improve your productivity and help you customize VS Code to your needs. Now the icons on the bottom is for your account and to adjust your settings. Now on the bottom of the screen is the status bar here in blue. On the left side, you will see any errors or warnings in your code. And on the right side, I see the line number that I'm on for my current file. And I also see the programming language being used. So let's say if I wanted to add another file to my project, rather than always having to click on this icon, I can use the keyboard shortcut of Command and N or Control and N on Windows, open up a new file. And on the bottom right, we see that this is identified as plain text. So now if I want to save this file as a JavaScript file, I can do Command S and I can name it as second program.js. And now on the bottom right, we see that VS Code can identify that this is a JavaScript file. The next thing I want to cover is the command palette. You can access the command palette by going to View and then Command Palette. Now another way to do that is with the keyboard shortcut of Command Shift and P, or it will be Control Shift and P on Windows. Now the command palette is very important as it is the control center for all commands in VS Code. From here, we can also adjust the color theme that we use. So I click on Color Theme, and as I scroll up and down, we can see different color themes for my code editor. You can also access additional themes by going to the very top, clicking on Browse Additional Color Themes, allowing you to search through different options. Now for this course, I'll just stick to the standard Visual Studio one. Now to make the text larger, you can do Command and plus or Control and plus on Windows, and also Command minus or Control minus in order to make the text smaller. So this is a quick overview of VS Code, teaching you the basics that you need for this course. Before we get started, if you're interested in supporting my courses and projects, you can follow me on my new YouTube channel and Instagram at StephenCodecraft. And if you're looking to enhance your health and fitness routine, check out my workout and meal planning app at fitfuelplanner.com. The app offers over 100 recipes, workout plans, meal plans, and a grocery list feature. It's designed to make tracking your calories and macronutrients straightforward and stress-free. I appreciate your support, and I'll see you in the next section. With the VS Code open, let's start our first program. We will start by creating a new file by clicking the icon on the left Explorer, and we can name this file whatever we want. I'm going to name it variables, and I'm going to use the file extension of .js for a JavaScript file. So in JavaScript, our applications need to work with information, such as an online shop where the information might be the product sold or info about the user. Variables are used to store this information. In programming, we would refer to this information as data. In our applications, we create, read, update, and delete data. We need a way to keep data in memory so that we can perform these operations on it. And to do that, we use variables. A variable is a named storage for data. So variables store data temporarily in a computer's memory, and under the hood, it will be stored in a memory location, and we can access that data stored by the variable name that we give it. So to declare a variable, the old way of doing it was using the var keyword. I'll show you an example of that. We use the var keyword. Now we name the variable. I'll use the name first name, and then I will assign it to data. So I assign it to the word, being my first name, and I use single quotes in order to tell JavaScript that this is a string of characters. So programmers, we refer to words as strings. We could also use double quotes, and both work fine in JavaScript. Now, using the var keyword is the old way of doing it. Now, the modern way of doing it is to use the let keyword in order to initialize this value. I'll talk about the differences of these conventions later in the course after you're comfortable with the basics. So this statement here that I highlighted is known as initialization. Note that we could also declare this variable and assign it on two different lines. I'll show you an example of that. And then we do first name and assign to our value. So this first statement, which I have highlighted, is the declaration. I'm declaring a variable. Then I am assigning it on the second line. Note that on the second line, I did not have to use the let keyword again. I only have to do it once when I first create it. Note that the single equal sign is known as the assignment operator, and that's the operator I use to connect data to the variable I have declared. Note that there are some reserved words that I cannot use as my variable name. I'll show you an example of that. So we use our let keyword to create our variable, and I'm going to name it function. which is a reserved keyword. And then I will assign it to a string saying test. So here VS Code indicates with these underlines that this variable name is not allowed. That's another benefit of using VS Code because we can catch errors early on in our development. So let me delete this. So note, when I declare this variable, right, just declaring it again, I use camel case notation for my variable name. And this helps with readability, and it's a common convention in JavaScript. So what you do is the first word that you use for your variable, you will have that in all lowercase, and then any preceding words, you will start the first letter uppercase and the rest of that word in lowercase. And this allows you to have descriptive variable names that are easy to read, as opposed to if I were to do something like this, which is just less readable. Okay, we can also declare multiple variables on the same line. So here, if I, instead of doing the semicolon, I use last name and assign it to my last name, and then end the statement with a semicolon. Semicolons tell JavaScript that this is the end of the line. But this becomes hard to read, especially when working with larger programs, so we prefer to put every initialization on its own line. So a real life analogy. Let's say we have a let message, and we assign it to the string hello. How does this look like visually? So to grasp this visually, consider this first screenshot. So you can think of our variable as a box. That's the amount of memory that JavaScript has allocated for us. To grasp this concept, visually consider this diagram. We declare a variable, which we imagine as a box for data, and this box has a sticker with the word message on it, which is the name of our variable. Then we store the value hello in it. We could also change the variable as many times as we like. Let's say if I do message and I assign it to world, ending with a semicolon. Well, visually to grasp this, so the previous string, which I had as hello, will be garbage collected by JavaScript, and that new string that we assigned it to will be stored in the memory location. So in order to run this program and to log it to the console, we can use a built-in function in JavaScript known as console.log. I'll do console.log, and I'll pass in the name of my variable, message, ending it with a semicolon. Now to actually run this program, I'll open up the panel. You can open up the panel in VS Code by doing Control and backtick as the keyboard shortcut, or if I close that, you can go View, Appearance, and then Panel to open it up. So here, in order to view what files I have in my project, I can do ls, and that's list out the files in my folder, also known as my directory. And here I see variables.js, which is the file I want to execute. I'm going to execute this with node. So I type in node variables.js, and here I see the value of my variable logged out to the console. Let's take a short quiz to test what you learned. This part is essential to ensure that you retain the information. What is a variable? A variable is a named storage for data. How do you declare a variable? You declare a variable with the let keyword. In JavaScript, we use the let keyword for variables which hold a value that can be changed. To declare a variable which has a constant value, which can't be changed, we would use the const keyword. An example of this would be const, if I name it Christmas 2024, and I assign that to the string, say 12.25.2024, ending it with a semicolon. So when a programmer is sure that a variable will never change, they can declare it with const to guarantee and communicate that fact to everyone. Here, if I log it out, console.log, Christmas 2024, opening up the panel, I can say node, variables.js, and here I see that outputted. Now with the const keyword, if I were to try to reassign it and then log it out, JavaScript would display an error. So let's say, before outputting it, let's say if I did Christmas 2024, and I assign that to 12.26.2024. When I try running that, it will display an error. So if I go up and run it, so here it is an error saying that I cannot assign to a constant variable. So another convention when doing constant is to use all uppercase to denotate that this is a constant value. Here, I will use all values where each word is all uppercase and separated by underscore rather than using camel case. Now, the use of this is not required and it depends on the convention of your team. One thing I want you to take away from the first two videos of this section is that I have been using descriptive names for my variables. This helps me write code that other people can easily understand. Now, I could have named this variable as const n equals green, but other programmers will not have context of why I initialized this constant value. So always use descriptive names for your variables. What is the purpose of a constant? The purpose of a constant is to define data that cannot be changed. What is the difference between a constant and a variable? A variable defines data that can be changed and reassigned later in the program, whereas a constant defines data that cannot be changed. In JavaScript, the data that we use can belong to either two categories, primitive value types and reference types. There are 8 basic data types in JavaScript. Primitive types refer to simple, fundamental data. Examples include string, number, big int, boolean, undefined, null, and symbol. The reference data type is the object data type. Don't worry about memorizing this right now, just focus on understanding and it will become second nature over time. So let me show an example of each of these. So I can initialize strings 3 different ways. I can say, let favorite fruit. I'll assign that to strawberries using single quotes. Then I'll create a string and I will initialize it with double quotes. Assign that to chocolate. Then I can use backticks, which will create a template literal. So I can say let favorite programming language assigned to JavaScript. Now these are the 3 different ways that we can initialize a string data type. Now we can cover numbers. Let's say if I do let number of donuts, I'm going to assign that to 12. Now numbers encompass both integer values and decimal values. So if I say let pi, then I can assign that to 3.14. Let's say if I do let very large number, type out a large number, and then end it with the character n. Now to show an example of a Boolean data type, which stores the value of either true or false, I can say let loves coding, assign that to the value of true. Now the undefined data type, this means that a value is not assigned to a variable. So if I just declare a variable, let's say if I do let favorite color, then by default it will be assigned the value of undefined. So if I console log that, I'll see the value of undefined. Favorite color. Opening up the panel and then running it. Up arrow and run. Here I see its value is undefined. Now for the data type null, we use null when we want to explicitly clear the value of a variable. So if I do favorite fruit, I can assign that to null. We also have symbols which are used to create unique identifiers and objects. So if I can do const and I'll say unique key, for example, assign that to symbol and then open and closing parentheses. Now, the last data type is a reference data type, and that is an object. So an object is known as a reference type. Primitive values can only contain a single thing, whether it be a number or a string. Objects can have a more complex structure, and they hold key value pairs. This enables us to store more than one variable all in one. So for an example, I can say let course, assign that to opening and closing curly braces. So this defines an object literal, and I can define a key. So I'll say name, set that to JavaScript for beginners, comma, and then I can define another key, hours, with the value of 3. And I can end it with a semicolon. So objects enable me to create more complex structures. Now we can use the type of operator in JavaScript in order to return the type of the operand. And that operand could be either a variable or a value. So if I open up the panel, if I just type node, so when we use the type of operator, then it will return the data type as a string. So if I do undefined, here we see undefined returned as a string. Now if I do type of 0, we'll see that data type is a number. Now we'll try it for a big int. If I do type of 10n, we get big int. Let's have it do type of taco, we'll get a string. Let's do type of a symbol. Now for the last example, I'll say type of null. So the result of type of for null is an object. Note that null isn't actually an object. The type of output for null being an object is from the early days of JavaScript, and it has remained for backwards compatibility. So to quickly recap, there are 8 basic data types in JavaScript. Of those 8, 7 of them are primitive data types, which include number, big int, string, boolean, null, undefined, and symbol. And for non-primitive data types, we have the object data type, which is a more complex data structure. What are primitive data types in JavaScript? Primitive data types refer to fundamental values. These values can only contain a single thing, whether it be a string, number, or boolean. What are the 7 primitive data types in JavaScript? The 7 primitive data types are string, number, boolean, big int, undefined, null, and symbol. Programming languages that allow you to initialize a variable to a data type and then reassign it to a different data type are known as dynamically typed. In other languages, such as C# or Java, you specify the data type that you want to use and cannot reassign it to a different data type. JavaScript is dynamically typed, so a variable is not bound to only being assigned to one type. So, to show an example of this, if I initialize, let first name, and assign it to the string of Stephen, then I can reassign it to a number. Say if I assign it to the value of 100, then I can reassign it to a boolean. So here we see that we can assign any data type value to our variable. Since it is dynamic, the type of our variable can change at runtime. Here, if I were to console log the types, I can do console.log type of first name. I'll add some spacing, and I'll copy and paste some here. So I'll output it. Node variables.js. So here I see the different data types based on what I assigned it to be. Now in a professional setting, you can see how this could potentially cause bugs in our application if someone were to assign it to a data type that doesn't make sense. So we need to be careful of that, and in professional settings, you would often use a version of JavaScript known as TypeScript, which is a statically typed version of JavaScript with enhanced features. What is dynamic typing in JavaScript? Dynamic typing refers to the ability to initialize a variable to one data type, for example a string, and to assign it to any other data type, whether it be a number, a boolean, or an object. Objects are reference types. In JavaScript, objects are used to represent an object or noun in real life. It contains state and behavior, enabling us to group together related values and make our code cleaner. Object literal syntax uses curly braces. So if I initialize an object, I'll say let course, assign to, curly braces, then I can specify a key, I'll name it name, with the value of JavaScript for beginners. So name is referred to as a key, and this string is referred to as a value. Now I can add more key value pairs by adding a comma, and then specify hours, and then I'll say 3, end it with a semicolon. Now I can console log this object, console.log, course, opening up the panel, node, variables.js, and here this outputs the object. So the key value pair, when considered together, is referred to as a property of the object. And all the keys are represented internally as a string. So in order to access these properties, we can do so through two different notations. The most common notation is dot notation. So after course, I can say dot name, and this will output the associated value for this key. So if I run it again, here I see it outputted the associated value. We could also reassign a property. If I say course.name and assign to JavaScript fundamentals, ending it with a semicolon. Now if I copy this and paste again, I'll see that it has updated that value. Clear the panel and then run again. So here I see the associated value has been changed. Now we can also access these properties using bracket notation. So if I comment this out, then if I do console.log course, then square brackets, and then specify the key as a string. So I'll say name, and then I'll output it. So this is a different syntax to accomplish the same thing. I could also use bracket notation to update the value. So if I do course name and assign it to JavaScript 101, then I'll output it again. And this displays the updated value. So which approach is better? Dot notation is more commonly used. However, you would use bracket notation in the case when you don't know which target property you want to access until runtime. Here, if I comment this out. So to show an example of this, I'll initialize a variable, let property, and assign it to hours. Then I'll do console.log, the name of the object, which is course, and using bracket notation, I will use this variable as the key. And this will output the associated value for the key of hours. When I run in the panel, it outputted the associated value. What is an object in JavaScript? An object is a fundamental data type in JavaScript that allows you to store key value pairs. You can use the object literal syntax by using curly braces and define the key value pairs inside of it. Are objects a reference type or a primitive type? Objects are a reference type. Primitive types refer to values that hold a singular value, such as a string, number, or boolean, whereas objects are a more complex data type that allow you to store multiple key value pairs. Objects allow you to store key value pairs, but often we need an ordered collection where we have a first element, second element, and so on. This data could be a list of products to display on a web page. Arrays are used to store lists of data. We would use square brackets to create an array literal. For example, we can do let product colors, and we will use the square bracket notation. And here I will just store some strings, ending it with a semicolon. And so here I'll just console log it, product colors, opening up the panel. And here it logs out the array, our list of data. Now, if we just want to access one element in our list, we can do so through bracket notation and access it by the index. So an interesting thing about arrays is that we begin counting from 0. So rather than counting the first element as the first element, we say that this is at the 0 position, and then 1, and so on. So here if I log it out, here I see it logged out blue for the first element in our array at the 0 index. So the type of variables of each element can change at runtime. In JavaScript, you can have different data types in an array. To demonstrate that, so before I console log, let's say if I do product colors at the index at 0, and I assign that to 42, log that out. Here I see it logged out the number value of 42. However, in a real-world project, you would keep the data types the same. This is just to demonstrate the flexibility of JavaScript. Note that an array is an object. Objects have key value pairs. In this case, the key is an index value. So here if I were to log out the type of, let's do console.log, type of product colors, opening up the panel again in our terminal, let's log it out, and we see that the data type is an object. A useful property that you'll often use when working with arrays is the length property. Product colors dot length. So just like we know our objects have properties, arrays in JavaScript have built-in properties. So here I will log it out, and we see that there are 2 elements in our array. What are arrays? Arrays are a data structure in JavaScript that allow you to store lists of data. How would you determine the length of an array? Arrays have a built-in property called length that allows you to find the length of the array. How would you access the first element of an array? You start counting from the index of 0 in order to access the first element. You would use square bracket notation to access the element or to change the value of the element. Functions are the building blocks of our applications. It allows us to group together statements to perform a task or calculate a value. To show you an example, we will use the function keyword, and we can name our function using camel case. We use these parentheses to denote any argument values we can pass in, and I can do console.log, end it with a semicolon. Note that we don't need a semicolon at the end of this curly brace. And then to actually have JavaScript execute that code for us, I can do say hi, and then call it by passing in the parentheses. Here if I open up the panel and execute this code, I see that it executed the code within the curly braces. We can also define a parameter variable. So here if I add in name, I can name this whatever I want. Then to actually output it, or to actually utilize that, I can do a plus sign and add in the name of the variable. So when working with strings and using a plus sign, this is known as string concatenation. So I would combine these together, create a new string. So since I've defined this parameter variable here, I will need to supply an argument when calling it. So here I'll just pass in my name, save and open up the panel. So once again, it's view, appearance, and then panel. Clear that out and then run it again. And here I see it outputted the argument that I passed in to that parameter variable. So here we see there's not a space, and so let me add that in here. I'll add the space before this closing single quote, and let's run it again. What is a function? A function in JavaScript is a named piece of code. We use the function keyword, and then we can name the function whatever we want after we use parentheses and then curly braces. Within those curly braces, we define statements, and we can invoke or call that function in order to execute those statements. The benefit is it allows us to quickly and efficiently execute those statements without having to duplicate our code. What is a parameter variable? When defining our functions, we specify a parameter list within the parentheses. When calling our function, we can pass in values, and that will allow us to customize the execution of our function. So we know that functions are a building block in our programs. They enable us to group together a block of code, which is a set of statements defined within curly braces. One thing I wanted to clarify is the purpose of functions. We create a function for one of two options. The first is to perform some action, and the second is to calculate and return some value. So not all functions require us to explicitly use the return keyword. By default, if we don't supply an explicit return value, then JavaScript will have the function return the value undefined. I'll show you an example of that. So if I declare a function, I'll name it multiply, and I'll specify two parameters, num1 and num2. Then the curly braces to define our code block, and then I will return the product of num1 times num2. So now if I were to call or invoke that function, I can say console.log to output its result, and then I will call it. I'll say multiply, passing in 2 times 2. Save it, open up the panel, up arrow and run it, and here I see the result of 4 was outputted. Now if I did not use this return keyword, and if I were instead, for example, to store it in a variable, const product is assigned to this operation, then JavaScript will return the value of undefined by default, since I did not supply an explicit return keyword. So if I run it again, here I see the return value multiply was undefined. What are the two reasons to create a function? You would create a function either for it to perform an action or to calculate a value and return that value. Let's summarize what we covered in this section. If this is your first time learning this, I don't expect you to memorize everything from the start. With continued practice, you will pick it up and it will become second nature. Be sure to view the GitHub repository associated with this project and review the project files related to this section. So variables are used to store temporary data. Data can be categorized into 8 different data types. Of these 8 data types, 7 of them are considered primitive data types. They are called primitive data types because they are singular values or simple values. These primitive data types are strings, numbers, booleans, null, undefined, big int, and symbol. And the 8th data type are objects. Objects are key value pairs, and they are not a primitive data type because they are a more complex data type and don't just store a singular value. There's also a built-in data structure called arrays, which stores lists of data, which is one of the most used structures that you will use as a developer. We also covered functions, so rather than having to copy and paste code and duplicate it, we can simply name a block of code, which is just a group of statements. Great job on completing this section, and with that, I'll see you in the next section. In JavaScript, we can operate on our variables by using operators. These include arithmetic, assignment, comparison, logical, and bitwise operators, which serve as fundamental building blocks for our applications. We'll be diving into each of these in this section. An expression in JavaScript is something that produces a value. An expression goes on the right side of our variable assignment. So in JavaScript, we have different mathematical operators, which include subtraction, addition, multiplication, represented with an asterisk sign, division, represented by a /, and the modulo operator. So modulo is the remainder of division, and it's useful as it helps us determine whether a number is even or odd. So let's open up the panel and type node and enter. So now that we're in interactive mode, we'll go through different examples. So if I do 2 plus 2, that results in 4. Likewise, if I do 4 minus 2, we get the result of that. So an example of multiplication, an example of division with the / symbol, we get 2. Now an example of the modulo operator, let's say if I were to do 10 modulo 2. So what this says is 10 divided by 2, and it will return what the remainder is. So return 0, so we know that this is an even number. Likewise, if I did an odd number divided by 2, then we get the remainder of 1. We could also raise to the power of, let's say if I do 3 raised to the power of 2, and that results in 9. Now we also have the increment and decrement operators. So if I initialize, let a is assigned to 10. Now if I want to update this value, I can say a is equal to a plus 1. Now JavaScript provides a shorter syntax where we can use syntactic sugar and say a plus equals 1, which accomplishes the same thing. Now we can do it even shorter. We can do a plus plus, and this will increment the value. We could also increment by doing plus plus a. Now the difference is the following. When I have the two plus operators after the variable, it will return the current value stored at the variable a, and then it will increment it after. If I have the two plus operators before the variable, then it will increment the value, then it will return that updated value. This same functionality also applies for decrementing the value. I demonstrate that, such as a minus equal 1, or I can do a minus minus, or minus minus a. What arithmetic operators are available in JavaScript? Arithmetic operators are symbols used in programming languages, including JavaScript, to perform common mathematical operations on numbers. These include addition, subtraction, multiplication, division, modulus, increment, decrement, and exponentiation. If I declared let num assigned to 1, how would I increment it? There are 4 ways to increment a number in JavaScript. You can do num is assigned to num plus 1, or you can use the shorthand of num plus equals 1, or the syntactic sugar of num plus plus, or you can do it incrementing before the variable name. You are familiar with the assignment operator being a single equal sign, such as let programming language assigned to JavaScript. The single equal sign does not actually check for equality in JavaScript. It's an important distinction that it stands for assignment, as in assigning a value to a variable. Later in this section, I will show you how we can check if two variables or two values are equal in JavaScript. What does the single equal sign stand for in JavaScript? The single equal sign stands for the assignment operator, and we use it to assign a value to a variable. When dealing with numbers, we often use comparison operators. These comparison operators include greater than or equal to, less than, and less than equal to. The result of using comparison operators in an expression is a Boolean value, so it will result in either true or false. I'll show you an example of each of these, and it will make more sense. So I'm going to declare this variable. I'll say let num1 is assigned to 14, and I'll say let num2 is assigned to 10. Then I'll declare a constant. I'll call it is num1 greater, and I'll assign that to num1 and then greater than num2. So what I have highlighted here is the expression, and this will result in a Boolean value, so a true or false value that will be stored in this variable. So I'll log it out, console.log is num1 greater, and let's log it out. So in the panel, I'll say node control flow, and I see that is true. So it results in a Boolean value. So let's consider the other scenarios. I'll just rename this variable to make it more descriptive. I'll say is greater than or equal to, and just copy that over. And I'll change this comparison operator to be greater than or equal to. So open it up, and we'll just run it again. Now I'll show the case when I can change this comparison operator to be less than. So this is asking, is num1 less than num2? So I'll just rename this to be more descriptive. I'll say, is num1 less than? So the actual name of these variables is arbitrary, but I do want it to be descriptive for anyone reading this program. So this returns the result false. Now I'll check if num1 is less than or equal to num2. I'll just change the name of the variable as well. So is num1 less than or equal to? What are the comparison operators in JavaScript? The comparison operators are greater than or equal to, less than, and less than or equal to. For checking for equality for two variables, we can do so in two different ways. So we know that using one equal sign is for the assignment operator. Here if I just initialize some variables, say let b is assigned to 2 as a string. So one equal sign is not for checking equality. So to see if two values are equal, we can do so through two equal signs. So here if I do console.log a equals b. So this is known as loose equality when using two equal signs, because here I'm comparing a number and a string. So let's output this to see the result. So this results in true. The reason why is because this evaluates in JavaScript what is known as truthy. So let me show you the other way of doing comparison, which is with strict equality. So I would do console.log a equal to b. So using three equal signs is strict equality. For the first type, when doing loose equality, it converts it into a string by converting it to the same data type and then comparing the values. With strict equality, it compares it as is without doing any conversions. So I'll output it. So when doing loose equality, it evaluates to true. And the reason is because these are two different data types. We are comparing a number data type and a string data type. To show you another example of how JavaScript converts values with loose equality, I'll show you 1 equal to 1 represented as a string. And so even though these values are different data types, JavaScript will convert it for us. So it will evaluate to true. Let's comment these previous ones out here. Comment it out and comment that one out. So once I output it, here I see it evaluates to true. Likewise, if I were to do true equal to 1, JavaScript will convert these into Boolean values before performing the comparison with loose equality. All right, so in order to avoid this confusion, stick to strict equality and use 3 equal signs. What is the assignment operator? The assignment operator in JavaScript refers to using a single equal sign in order to assign a value to a variable. What is loose equality? Loose equality in JavaScript refers to the comparison of two values using 2 equal signs, without enforcing type similarity. When using loose equality, JavaScript performs type coercion if the values being compared are of different data types, attempting to convert them to a comparable form before making the comparison. This process, known as type coercion, can lead to unexpected results if you're not aware of how the values are converted. These 3 examples show how JavaScript would perform loose equality. What is strict equality? Strict equality refers to using 3 equal signs for checking for equality. This will return true if the values are equal and of the same data type. In JavaScript, we have something called a ternary operator. So the ternary operator is a conditional operator that allows us to write cleaner code. Oftentimes, you'll need to perform a comparison and store values. Let's go into an example. Say let age is equal to 16, and I want to determine if I can drive. So then I can perform a comparison, so age greater than equal to 16. Well, in that case, I can use a question mark and then true or false. So let's break this down. Highlighted, I have the comparison, comparing the value at this variable and this number. So this question mark is the ternary operator, which means that if this results to true, then it will return true. Otherwise, return false. Let me console log it, console.log, can drive. Opening up the panel is control and backtick, or view appearance panel. So up arrow, execute it, and we know that it's true. So now I will comment this out since we no longer need it for now. And I'll pick another example. Let's say let points is equal to 110, and the output to determine what the customer type is. So if points is greater than 100, then in that case, we determine gold in the case when it's true, or silver in the case when it's false. So I'll output it, console.log, customer type. So what this does, this allows us to perform an assignment to the customer type variable that we declared conditionally based on the result of this comparison. So once again, I'll output it, note, and we see that the customer is a gold customer type. What is the ternary operator? The ternary operator is a way to conditionally assign a value to a variable. You would use a conditional expression followed by a question mark. If that conditional expression is evaluated to truthy, then you'll use the value that follows just after the question mark. Otherwise, you'll use the value following the colon, which is specified at the end. What is the value stored in the variable customer type? The value stored will be the string containing the word gold. We use logical operators to make decisions based on multiple conditions. There are 4 logical operators. The logical operators are the OR operator, the AND operator, NOT, and no coalescing. These can be applied to values of any type, not just Boolean. Starting with the OR operator, which is represented by 2 vertical lines. So there are 4 possible logical combinations, and I'll show you each. I'll console log true and use the logical OR operator, represented by 2 vertical lines. In this case, I'll just do true. So what this expression does, the expression that I've highlighted, true and true, as long as one of the operands is true, then it will return true. So I'll just log that out, null operators.js. So we know that. The other option is if the first is false and this value is true. So in this case, we know that as long as 1 is true, then it will return the value as expected. Right, so we know that. Now, if the first is true and this is false, same result as expected, then we log that out. And the last option will be when they are both false. Pull out the panel and run it one more time. So long as one of the operands is true, then the expression will evaluate as expected. Now, if operand is not a Boolean value, then it will be converted to a Boolean value for the evaluation. For example, the number 1 is treated as true and the number 0 as false. So the OR operator is evaluated from left to right, and for each operand, converts it to a Boolean, and once it finds an operand that resolves to true, it stops and returns the original value of that operand. And if all operands have been evaluated to false, then it returns the last operand, and the value is returned in its original form without the conversion to a Boolean value. Now to show you another example, we'll say let has reservation. I'll close the panel, assign that to true. Then I'll say let accepting walk-ins and assign that to false. If it has access to table, has reservation, or accepting walk-ins. Log that out. Open the panel or run it. And we see it evaluates to true. Now let's consider the AND operator. So AND returns true if all the operands are truthy, and false otherwise. I'll show you all possible combinations. True and true, so we know that's true. And I'll just copy it the other 4 times for the other cases. Now all other cases will be false. So we have false and true, true and false and true. Run in the panel, node operators.js. And here we see as expected. So this operator evaluates from left to right, and once again it converts each operand to a Boolean if it is not already a Boolean type. And once it discovers one of the operands to be false, then it stops execution, which is known as short circuit evaluation. So to show you a more real world example, let's say let age equals 16. I can say let has car equals true. And let's say const can drive age is greater than or equal to 16 and has car. Now let's log that out. Here it evaluates to true. So note that the precedence of the AND operator is higher than the OR operator. So just to give you a visual of that, console.log let's just make it let A equal true, and B equal true, and C equal true, and D equal true. Then if I were to write this expression, I can say A and B, or C and D, then this value up here is actually the same as this, as if we were to write parentheses, just to show that using the ampersand holds higher precedence and is evaluated first before the OR operator. So just to demonstrate that. Next is the Boolean not operator represented by exclamation point. So it converts the operand to a Boolean type, true or false, and it returns the inverse value. So let's just say if I were to do console.log of true, then whatever this current value is, it will return the inverse. It will return false in this case. Here we know it evaluates to false. So let's say if I were to do let is closed on Sunday, defined to true, then I can say const is restaurant open to is closed on Sunday. Then I can console log it. Then I can run it. And here we see it returns the inverse of this value. So let's close that. So the last operator is the nullish coalescing operator, represented by 2 question marks. If a value is null or undefined, then we can supply a default value. Show you an example of that. Let's say let A, let's just assign it to null. And we want to determine what the result is. So if A is truthy, right? So in this case, it is not. So we need to apply a default value. So we use the null coalescing operator here. So this being the default value. So if I just log it out, result, and then I'll execute it in the panel. I'll do node operators.js. And here we see it evaluates to false by being given the default value. To make better sense of this, I'll show you that this is actually syntactic sugar. If we were to do the longer format, it would be A not equal to null and A not equal to undefined. And then using the ternary operator, which is a question mark. So this expression, this condition is evaluated. And if it's true, then return A. otherwise return false. So what we did before is just the shorthand version of this, and it provides syntactic sugar and cleaner code and easier to read for us. What are logical operators? Logical operators in JavaScript are special symbols or keywords used within expressions to perform logical operations. They primarily involve Boolean values, however they can be applied to values of any type, not just Booleans. The result of these operations is to determine the logical relationship between the operands, typically resulting in a Boolean value that indicates the truthiness or falsiness of the combined expression. What are the four main logical operators in JavaScript? The four main operators are the AND operator, the OR operator, the NOT operator, and null coalescing operator. What is this operator and how does it work? This operator, represented by two vertical lines, is the OR operator. It compares two operands, or two values, and as long as one of them results to true, then the expression will return true. What is this operator and how does it work? This operator, represented by two ampersands, is the AND operator. The way it works is it compares two values, or two operands. When both operands results to true, then it will return truthy. What is this operator and how does it work? This operator, represented by the exclamation point, is known as the NOT operator, also sometimes called the bang operator. So this value returns the inverse of the operand that it is used with. For example, if the exclamation point is used in front of a variable and that variable is assigned to the value true, the exclamation point will have it return the inverse, so it will return false. What is this operator and how does it work? This operator, represented by two question marks, is the null coalescing operator. What this does is it allows you to supply a default value in case the operand used in front of the question mark is false. JavaScript is different from other programming languages. One way that it differs is in its use of logical operators and how they can be applied to non-boolean operands. So I'll pull up the panel. You can go to View, Appearance, and then Panel. So if I were to enter node and compare false or the string Stephen, here we see Stephen is returned. Using the OR operator, it returns the first true value, so you see that this string is evaluated to true. So in JavaScript, the result of a logical expression is not necessarily true or false. So it looks at the operand, and if it's not a Boolean value, it will then try to interpret it as truthy or falsy. So in JavaScript, something that is falsy, which is different from the Boolean false, encompasses the values of undefined, null, zero, false, the empty string, and not a number. Anything not falsy, anything which does not fall in the category that I previously mentioned, is considered truthy. Now to show you another example, you can consider false, or 1, or 2. The result of this is 1. JavaScript evaluates this from left to right. Since 1 is considered truthy, then JavaScript can perform short-circuit evaluation and return immediately. This means that JavaScript will stop once it can successfully determine the result, and it doesn't have to evaluate every operand. So to provide a more real-world example, let me initialize user's chosen color is assigned to blue, and we'll say the default color is green. Now we can determine what is the current website color. So I'll say user chosen color or default color. I'll console log it. Current website color. Because both of these values are strings, JavaScript will convert these to Boolean values and consider whether this is truthy. Node operators.js. And here it evaluates to blue, but if I were to delete blue and it'd be an empty string, then JavaScript would evaluate that to be falsy, and it would return the default color. What does the term falsy mean in JavaScript? So this term applies when you're using logical operators with non-Boolean values. Since logical operators deal with Boolean values, which means values that are true or false, if you're using a non-Boolean value, such as a string or a number, JavaScript needs to be able to convert that value into a Boolean value, into a true or false value. What are the falsy values? JavaScript has a set of non-Boolean values which it considers to be falsy, meaning that when JavaScript converts these non-Boolean values into Boolean values via type coercion, it evaluates to false. The falsy values consist of null, undefined, not a number, the empty string, zero, and false. These are the values that JavaScript will consider to be false. How do logical operators function when applied to non-Boolean values? Logical operators are evaluated from left to right. If you're using the OR operator, once JavaScript evaluates an operand to be truthy, then it will return that value. If you are using the AND operator, then all the operands need to evaluate to truthy. In the case when it's true, then it will return the last value in the expression. Consider the expression let name assigned to the string test and const result equal to false or name. What is the value stored in the variable result? The value stored will be the string with the word test. So operator precedence. I'll initialize this variable, 5 plus 5 times 4, and then I'll console log the result, console.log, and then n. Your node, operators.js, and here it evaluates to 25. So previously in JavaScript, everything has been evaluated going from left to right for each statement. But here when using operators, it will use the same order of precedence used in math, that being parentheses, exponents, multiplication, division, and then subtraction. So in order to make this more readable, usually we would use parentheses just to make it more readable for other programmers who are viewing our code, but JavaScript does this under the hood. So I will save it, and this will return the same result for us. But here it's just a bit more readable. Now we could also override that precedence by utilizing parentheses. To summarize the section on operators, we covered the arithmetic operators, which include addition, subtraction, multiplication, division, and modulo. We covered the assignment operator, which is used for assigning values to variables. We covered the comparison operators, which use greater than or equal to, less than, and less than or equal to. We covered the equality operators, such as loose equality, which uses two equal signs, which will have JavaScript perform type coercion and compare the underlying values of the operands, irrespective of the data type. Instead, we should use strict equality, which uses three equal signs to ensure that we are checking that the values are the same and the data type is the same for the operands that we are comparing. We covered the ternary operator, which provides syntactic sugar for conditionally assigning a value depending on a condition. So if the condition is true, use the value specified after the question mark. If the condition is false, use the value specified after the colon. We covered the logic operators, which include the OR operator with two vertical lines, the AND operator, which uses two ampersands, and the NOT operator, which uses an exclamation point. This concludes this section, and I will see you in the next one. So now I'll rename this file to control flow. Control flow. So programming is powerful as it enables us to execute different code based on conditions. This is what enables us to provide dynamic and personalized applications to end users. The fundamental programming concept that enables this is conditional statements, more specifically, if-else statements. So previously we have considered, let's say if I were to do price of chocolate equal to the number, that decimal value, and let's say let has amount in cash assigned to 5, well, we can use comparison operators and store the result of this Boolean operation. You can say can buy chocolate equal to has amount in cash, and if that is greater than or equal to the price of the product, then we know we can determine whether this is true or false. I'll just log it out. Go to node control flow.js, and we know that that's true. Now if I were to log out instead, the type of this variable, and this will determine what the data type is. So if I execute that again, we know that is a Boolean result. So the result of these comparison operators, we know it will be a Boolean result. So we can utilize these comparisons and these conditions to execute different code. So if I were to utilize an if-else statement, I can say if, which is a built-in keyword in JavaScript, and I can utilize this variable in parentheses. This is known as a condition. Then I'll do curly braces, and within these curly braces, I can write statements that will be executed. This condition is true. So I can say console.log, enjoy your purchase. So now I'll execute this program, and we see the string enjoy your purchase. Now let's say if I were to make this person only had 99 cents in cash, then if I were to execute it, then we see that that is not logged to the console, as this is not true. It would be false in this case. So let's go back to setting the value to 5. Now rather than just logging out in the case when it's true, we can also log in the case when it's false by using an else statement, which is built into JavaScript, and we will log in this case console.log. Sorry, you do not have enough. So I'll execute both cases. Once again, when we get the result, so only this code is executed in this case, because this value is evaluated to true. Now, let's go to 0.99. Now we'll see which statement is executed and which is logged in the case when can buy chocolate is false. So here we see this was logged to the console. So to show you a different example and remove that, we have two types of conditionals in programming: the if-else statement, which is used most commonly, and we also have switch case statements, which I'll be covering in the next lesson. So let me consider a more evolved example to show you what else you can do with if-else statements. Let me initialize, let's say let hour is assigned to 10, for example. I want to do different conditions to determine what types of food a restaurant is serving based on the time. So let's say if the hour is greater than 6, and the hour is less than or equal to 12, then it would serve breakfast. So console.log serving breakfast. Let's log this out. So it's currently serving breakfast. Now we also want to consider the case when it would serve lunch. So let's say else if the hour is greater than or equal to 12, so we say it's greater than 12, and the hour is less than or equal to 14, then in that case we will log console.log serving lunch. So open this up and log it out. So let me change this value. Let's say it's 1 o'clock. Then we see that it's serving lunch. Now in the case when it would be serving dinner, let's say else. Now when we have if, else if, then the last statement would just be else. And in this case, we don't need to supply a condition, meaning that we don't need to do parentheses here, as this will be evaluated as the default case. Console.log serving dinner. So let's make this, and we'll log it out. So now you see the case of how we can utilize if-else statements to customize the output for the user. In the case when we just have one statement within the curly braces, now when I have this highlighted, this can also be referred to as a code block. So when we just have one statement within it, we can actually clean it up and remove the curly braces, just to make it a bit more readable and cleaner. What is the if-else statement? Control flow in programming refers to the order in which statements are executed. In JavaScript, control flow structures such as the if-else statement dictate how and under what conditions certain blocks of code are executed. Switch case statements can also be used for control flow. The difference between if-else statements and switch case statements is that switch case is only used for equality comparisons. So I'll show you an example. Let's initialize a variable, we'll say let job, assigned to the string of software developer. Now I'll show you an example of the control flow using if and else if statements. So I'll say if job is equal to, so I'll use 3 equal signs for strict equality, and then the string software developer. I'll do curly braces, and in that case I will console.log writes code. Save that, open up the panel, and I'll run it. So I'll say node control flow.js in here. Because this condition is true, it executes and console logs that string. I'll show some other examples. So I say less if job is equal to a designer, curly braces, and I'll say console.log makes user interface documents. End it with a semicolon. Now, if I were to assign this variable to be assigned to designer, and I run it again, here it executes this console log statement. I'll show another example, else if your job is equal to, we'll say cloud engineer, console.log manages and deploys cloud resources, right? So let's say if I assign this value, and I run it again, console logs that, and I had a default with the last else statement, console.log, I'll say works directly with customers. I'll just say sales. Run it, and executes this last else statement. So since we are using our if-else conditions to do comparisons with the equality operator, this can be a bit hard to read and repetitive. When you find yourself having a long chain of if and else if statements, when you're using comparisons for all the conditions, you can consider using switch case statements. So instead of the code above, I'll comment it out by highlighting it and doing command / or control / on Windows. I'll use the syntax where I say switch as the keyword, and for the condition, in the parentheses, I will specify the variable. Then what I'll do is I will use the keyword case. So in the case when it's equal to software developer, colon, then I will console log this statement, and then use a keyword break with a semicolon to end the comparison. Then I'll say in the case when it's a designer, colon, then I'll copy this over. So I'm effectively implementing the same functionality, just using different syntax that's easier to read. copy this over with a break statement, and then I'll add a default. So this is another way to achieve that same functionality. Now, the reason why we use the break statement is that what the switch case statement will do is it will take this variable and it will compare it to every single case. And in the case when it is equal to it, then it would execute the code in this code block. So by specifying the break statement, we're telling JavaScript to break out of this switch case statement. So no longer perform any more comparisons and move on with the program. So we'll log it out. So in the case when it's equal to, I'll say software developer, and save it. I'll scroll down so you can see the code, and then I'll execute it. So this is a way to achieve that same functionality. Once again, when using switch case statements, this only applies in the case when you are doing equality comparisons. What are switch case statements, and when would you use it? Switch case statements provide a clean syntax in the case when you are using a variable and performing comparison equality. You can implement the same functionality using if and else if statements, but switch case statements provide a clean alternative for accomplishing the same thing. So to describe the syntax, you would use the switch keyword, then in parentheses, you would use a variable or a value, and then within the code blocks, you would specify different cases to define the case when that variable or value is equal to that case, and then execute code for that particular use case. When using switch case statements, you also want to remember to supply a default value. Next, we will cover for loops. So I will initialize an array, call it let numbers is assigned to, using our array literal syntax with square brackets. I'll do 1, 2, 3, 4, 5, 6, and 7, ending it with a semicolon. Now what I'll do is I'll initialize this number to be the index of 0, because we know when we start counting these elements, we start counting from 0. So for this index value in this element, this is at the 0th position, then the first position, second position, and so on. Then to determine what the length of the array is, I can say let length of array, and it'll be numbers, and arrays have a built-in property called length, so that can be stored here. So now what I want to go through and log each element in this array by referencing it by its index. So I will use bracket notation to access it by index. I can do console.log, so the name of the array, square bracket notation, and I'll do the index, and I'll log that out. So this executes, and this displays the element at the 0th position, the first position of the array. Now let's say if I wanted to output every single element, well, I could copy it over. So I'll do Shift Option and the down arrow just to copy it over 7 times. Now, each time I want to increment it. So rather than having to do this and then do index ++ to increment it, I can just do it within it. And I know if I do the increment after, then this will be displayed and then be updated after. So I'll continue this just for each one, except for the last one, and I'll log that out. So here you see this executes and this displays every element in the array. Now this was a very repetitive process and we won't want to do this in a real program. So I'll comment all this out and we can use it to reference it as we build up our first for loop. So for loops allow us to get the benefit and the power of programming because it can execute a lot of code in a very short amount of time. So we'll utilize the for keyword, which is a special keyword that allows us to create a for loop. And we can do initialization here. We'll say let index assign 0 and we'll do a semicolon. And then we can do while the index is less than the numbers.length, and then the index increments. And then I'll do curly braces. So I'll break this down. What we did here is just put the same logic on one line. So we initialize our variable index to keep track of where we are in the array. Then we have a condition. So is this index value less than the numbers.length? And this will evaluate to a Boolean value. While it's true, then the code within this code block, within these curly braces, will be executed. If it's false, then it will stop execution. Now we want to continue incrementing through the numbers array. So we need to continue to increment the index. Now if we were not have this, then this will result in an infinite loop, and this code will continue to be executed and our computer would crash. So it's very important to have this last value, incrementing it, to make sure that we are getting closer to this condition being false. So another way to think about this, if this is your first time seeing it, whenever we have these traditional for loops, we have an initialization part, we have a conditional part, and then we have an increment or decrement part. So Now in here, I'll just do console.log numbers at index. So using this variable to reference the element that we want to execute. So I'll execute that, and we get the same result with much cleaner code. So loops reduce our code duplication, and they have fast execution. So here it's executed with an array with 7 elements. But let's say if I were to do another for loop, let's comment this out. So command / or control /. Let's say if I do for our initialization part, let num is assigned to 0, while num is less than a value like 100, and let's say the number increments, right? Initialization, condition, and then increment or decrement. So this value, the code will continue to be executed while this condition is true, and once it's false, it will stop its execution. So I'll do console.log, and let's execute the number. So here you see all these values are quickly executed, and I don't have to go through and do console logs for every single number. What is a for loop? In programming, a for loop is used in order to execute a code block repeatedly. So rather than having to manually repeat that code, which will lead to code duplication, you can define a code block defined within curly braces, and using the special syntax of the for loop, you can continue to repeat those lines of code while a condition is true. What is the syntax for a for loop? The syntax for the traditional for loop uses the for keyword, then you would define an initialization part, you define a variable, then you would define a condition, so while the condition is true, you will execute the code within the code block, within the curly braces. And then you would have an increment or decrement part, where you are updating the variable such that it gets closer to the condition being false, because you need to make sure that you break out of the for loop, because you don't want to deal with an infinite loop, which would cause your program and your computer to crash. We often need to repeat actions, and loops are a way to repeat the same code multiple times. You've seen the for loop, which provides a traditional syntax for iterating over an array. We use for loops when we know the exact time when we want the loop to stop executing. There is another syntax called a while loop, and we can implement the same functionality of for loops with while loops. So first I will show you the for loop again. So we'll say we know we have let index is assigned to 0. Then we have the condition, where we say the index is less than numbers.length. And then the index increments. Right, so we have the beginning part, the initialization, we have the condition, and then we have the step condition, where we're incrementing. Console.log, numbers at index. Right, since this is new syntax for you, I want to be repetitive just to make it easier for you to remember. Execute that. Now let's use a while loop to achieve the same functionality. So I will say let index is assigned to 0, and here I will use the while keyword. So in the parentheses, I will say index is less than numbers.length, and then curly braces. So in here I will say console.log numbers at index, and then the index increments. So I'll comment this out by highlighting it in control / or control / for Windows. So we see that this has the same parts, but it's broken up. So here we see the initialization part here, then the conditional part, and then the step condition. So now I'll execute it just to show you that we have the same functionality, and it executes the same functionality. Now the difference is that we would use a for loop when the number of iterations is known before entering the loop, whereas we would use a while loop in the case when the number of iterations is not known before entering the loop. So to show you one condition that shows this and demonstrates this, we can say if we have let sum is equal to 0, and we can just say while true, so while this condition is true, execute the code within the block. I can just say console.log loop, and then sum increments. Then I can do if the sum is equal to 10, then in that case we can use a break statement and break out of the loop. So this is a special keyword we can use within our while loop or a for loop to stop and break out of the execution. So I'll run this, and here we see we have console logged loop. So in this case, we have shown that we want this condition and this loop to continue to run while this is true, and we have this case to ensure that we don't have an infinite loop. So it doesn't run an infinite amount of times, and we know when to terminate it. And this is something that we cannot do with a for loop, meaning that we cannot just use a condition of while it's true, continue executing. What are the similarities and differences between the for loop and the while loop? The for loop and the while loop are similar in that they both execute a block of code repeatedly while a condition is true. The difference is that you would use a for loop typically for iterating over an array, whereas a while loop, you would use that in order to execute the same block of code while a condition is true. We have another loop we can use in JavaScript known as a do-while loop. Now, do-while loops are not commonly used, but I want to show it to you just so that you are aware of it. So previously we have used for loops and while loops where we specified a condition and then executed code within curly braces. And if and only if the condition evaluated to true, would that code block be executed. So the code in the code block was only executed after the condition. With do-while loops, we specify the code block first and then the condition after. So let me show you an example. Let's say if we do let I is assigned to 0. So we initialize that. Now we'll use this syntax where we say do, which is a built-in keyword in JavaScript. Then we can do console.log, let's say I, and then we increment it. Now we supply the condition after. So while I is less than 10, then we use a semicolon to terminate it. So this syntax will execute the code block first, right? Everything I have highlighted within the curly braces, and then do the condition check after to determine if the loop should continue executing. So with this syntax, it's guaranteed that our code block will execute at least once. So I'll save this and I'll execute it, up arrow, and we see it's executed. What is the difference between a while loop and a do-while loop? Both a while loop and a do-while loop are similar in that they repeatedly execute a block of code given a condition being true. The difference is that a while loop will check the condition first, and if it is true, then execute the code. With a do-while loop, it will execute the code first, specify within the curly braces, and then check the conditional statement. So a while loop is not guaranteed to run and will only run if the condition is true, whereas a do-while loop is guaranteed to run at least once. One thing I want you to be aware of when working with loops is the problem of infinite loops. So when working with either a for loop, a while loop, or a do-while loop, we must ensure that our loops terminate. If you were to simply do, for example, while true for the condition, and just do console.log of loop, then this will continue to loop and execute an infinite amount of times, and our program and computer would eventually crash. So when working with either for loops, while loops, or do-while loops, we have to ensure that we specify a condition in the parentheses that will eventually evaluate to false. Or we can explicitly use a break statement to explicitly tell JavaScript that we want the loop to stop executing. So once again, I'll show you the for loop. Let num assigned to 0, num less than or equal to 100, num increments, and once again we'll log out the num. So the two things I want you to consider here is the condition. So this loop will continue to execute while this is true. And so the step condition right here, we want to ensure that for each iteration, we are getting closer to terminating this condition, to this condition being false. So that's why we do num plus plus as opposed to num minus minus, because in this case, it will lead to an infinite loop. So whenever you're working with loops, be careful of the condition that you're using and the step that you are specifying to get closer for it to evaluate to false. What are infinite loops? Infinite loops can occur in a for loop, while loop, or do-while loop. This happens when the condition you define is always true. This will lead to the code block being repeatedly executed without being terminated. This will lead to your program crashing. How can you prevent infinite loops? To prevent infinite loops in your for loop, while loop, or do-while loop, you need to make sure that there is a step condition that is continually being updated so that for every execution of the code block, you are getting closer to the condition being terminated. You have seen the for loop many times, which shows us how we can loop and iterate over an array. We also have a syntax that allows us to iterate over the keys of a JavaScript object. Once again, a JavaScript object is a data type that allows us to specify key value pairs. So now I can initialize the object, const course, assigned to an object literal. I can specify the key of name with the value of JavaScript for beginners, comma. Then I can add duration, 3 hours, and sections, 7. I end it with a semicolon. Now, if I wanted to display each property or key of this object, I would need to do the following. Console.log, then I can access it through dot notation, course.name. I can also access the value through square bracket notation. If I do console.log, then course, square brackets, and then as a string, pass in duration, and the last property, console.log, course.sections. Save it. Then I'll run it in the panel, node, control flow.js, and this displays all the values. Now this is fine since we only have 3 properties, but let's say this object had 30 properties. Then this process would be inefficient. So we want to reduce our code's duplication and make it clean and easy to read by using a for-in loop. So I can comment this out. So the for-in loop is used with JavaScript objects to allow us to iterate over the JavaScript object and get access to the keys. So if I do for, then I can name it const key in course. So I can name this variable whatever I want. And then we specify the object that we want to iterate over. Then I will output it console.log of course, and then using square bracket notation, I will specify the key. So then I'll output it, and I get the same result. What is the for-in loop, and when would you use it? The for-in loop is used to iterate through the keys of a JavaScript object. You would use it when you want to efficiently iterate through the object and access its value. In the case when we are simply looping over the elements of an array, it can be bothersome to always have to write the traditional for loop. So once again, I'll show you full execution of that. So I initialize an array with 5 elements, then the traditional for loop, index.lane, index increments, console.log, and then we have numbers, and we access it by its index with the bracket notation. Let's execute this, clear it, go up again to re-execute each element of the array. So this is a lot of syntax to write, and in this case it's not needed because we are simply accessing the elements of the array. We would need this in the case if we were using this index variable for some other use case. But since we're not, I can comment it out, highlight it, and do command / or control / if you're on Windows. So if we simply need to access the element, we can use a different syntax called the for of syntax. And this is used for when iterating over an array. So once again, we use the for keyword, and I can say let element of numbers. So in this case, we use of, and this iterates over the elements of the array. Now in this case, I use the variable name element. You can name this whatever you want. I can call it numbers, for example, but I like naming it element. And also I use the let keyword for this being a variable. You could also have it be a const since we're not changing it. I'll name it as let, and then I'll console.log it. I'll clear this out, and then iterate and get the same result. What is the for of loop? The for of loop is a special syntax in JavaScript that allows us to easily iterate over an array. For each iteration, we get access to the element. You would use the for of loop over the traditional for loop in the case when you don't need to use the index that you are currently iterating on. Break and continue statements. So when working with loops, there may be specific conditions when we want to stop execution. The break statement means to break out of the loop's execution, and we would use this to terminate the execution of a loop. So this can be used for all the different loops that we have covered so far, which include the for loop, the while loop, the do while loop, the for-in loop, and the for of loop. Let me show you an example of each. For the for loop, we can say let I is assigned to 0, I is less than 10, and I increments. Now we can say if I is equal to 5, curly braces, then we'll say break. So this exits the loop when I is 5. So otherwise we want to console log it. Console.log I, and let's execute it. Clear this out, I'll go up, and let's execute each of the expected values, and stops execution once I is equal to 5. So I'll close this out, and I'll comment it out. Command / control /. Now I'll show you the same process with a while loop. So I can say let I is assigned to 0, while I is less than 10, if I is equal to 5, then we'll use break, right? Exit the loop when it's equal to 5. Otherwise, console.log. And since we're using a while loop, we need to make sure that we increment I, right? We get it to where it stops execution, so we don't get an infinite loop. So let's open up the panel again, view, appearance, and panel, and I'll clear it with Command and K or Control and K. We'll go up with up arrow and execute it, and we get the same expected result. Now I'll continue showing you for the other loops. Let's consider a do while loop. So let's say let I is assigned to 0. Now we use our do keyword and specify our code block within the curly braces. We'll specify our condition, so if I is equal to 5, with strict equality, and once again the break statement. Otherwise we console log I, and we need to make sure that we increment I, so we don't get an infinite loop. Now we specify our condition after, so while I is less than 10, we continue looping. So open up our panel again, clear it out, same expected result, right? So let's do our for in. The for in syntax is used with objects. So I can say const, and I'll just call this object, and I'll just specify it on one line. So we'll say the first key is A, and the value is 1. Then we'll say B, 2, and C, and 3. And I'll just add a semicolon at the end here. Now I can do for let key in object. Now I can name this whatever I want, and I could also use a const if I wanted, but I'm going to keep it a let. And I can check if the key is equal to B, for example. So when working with objects, each of these keys, in this case it would be A, B, and C, are internally represented as strings. So if the key is equal to B, then I'll break out. Otherwise, I want to console log it. So I'll say console.log the object at that key. So let's open up the panel and let's run it. So here we see it executes the value of 1, which is the value associated with the key A. So I'll close this out and comment it out. Our last one is our for of loop, and it's used for iterable objects. So this includes arrays and strings. So I can do const array is equal to 1, 2, 3, 4, and 5. And I'll say let element of array if element is equal to 3 with strict equality. Then I can break out. Otherwise, I will console log it. Open up the panel and we'll execute it again. So we get the values of 1 and 2. And once the element is equal to 3, then we stop execution. So I will clear everything out. Let's remove everything. Now let's talk about the continue statement. So the continue statement means that you want to skip the current iteration of the loop and proceed to the next iteration. And once again, this can be used for all the different loops that we have considered so far, and I'll show you an example for each. So the repetition is good because it really drills the syntax into your memory. So we'll say for I is equal to 0 while I is less than 10, and I increments. Now we'll say if I is modulo 2 equal to 0. So I'll explain what this means. So the modulo operator, which I covered earlier, this finds the remainder of division. So in this case, the remainder of dividing by 2, if that is equal to 0, this checks that if a element or if a value is even, then in this case, I will specify that I want to continue, meaning that I want to skip this current iteration and move to the next one. So then I will console log, in the other case, I. So another way to think of the continue statement, you can think of it as if it were skip. That's actually not a keyword in JavaScript, but that's a way you can think about it to better understand its purpose. Skip the current iteration and move to the next one. So I'll open up the panel and we'll execute it. And so in this case, we expect only odd numbers to be displayed since we're skipping over all the even numbers. So once again, it only displays the odd numbers because we're using the modulo operator, right, which gets the remainder of the division. So I'll comment this out. Now I'll show you the continue statement in the context of a while loop. Say let I is assigned to 0, while I is less than 10. Well, I'll say I increments, and if I modulo 2, right, so strict equality 0, so if that is even, then I want to skip to the next iteration. Otherwise, I'll console log it. Console log I, open up the panel, and let's display it, and it displays only the odd numbers, as expected. So I'll comment this out. Now let's consider a do while loop, so I'll say let I size 0, do, curly braces, I increments, if I modulo 2, 0, then continue. Otherwise, log it out. And we specify our condition, while I is less than 10. So I'm showing you the different way of doing it, of using the continue statement for all the different loops that we've covered so far. Right, same result, only displaying the odd values. Now, in the context of the for in loop, once again, for in is used with objects. I can specify const object, the curly braces, the key of A maps to the value of 1, then B and 2, let's say C and 3, and D and 4. And I'll add a semicolon here, and I'll iterate over it. So we have for let key in object. Now in this case, if the object, the key, right, so now we're checking the value, mod 2 is 0. Well, in this case, we'll want to continue it, right? So we want to skip over all the even numbers. Otherwise, we'll console.log the object at the key. So we'll only display the odd numbers in this case. So open up the panel, run it again. Only the odd values in our object. We'll comment it out. And our last example is for of, which is used for iterating over objects like arrays and strings. I'll specify const array is equal to 1, 2, 3, 4, and 5. Then we'll say let element of R, the array. Now, if the element mod 2 is equal to 0, right, the remainder of the division is equal to 0, then we know that it's even, and we want to continue, meaning that we want to skip over that. Otherwise, we'll log it out. Log of element. So let's open up the panel and we'll run it. Only the odd numbers in this case. So you can use the continue keyword like a skip keyword, and it skips over the current iteration and goes to the next iteration of the loop. What is the break keyword used for? The break keyword is used when dealing with control flow in for loops or in switch case statements. So when JavaScript encounters the break statement within one of these structures, it will stop the execution for that associated for loop or switch case statement. What is the continue keyword used for? The continue keyword can be used within for loops or while loops. So when JavaScript encounters this keyword, it will skip the current iteration of that for loop and skip on to the next iteration. Implement a function that accepts two numbers and returns the maximum number. So we'll create our function with the function keyword and we'll name it maxNum. Now we need to take in two parameter variables. So I'll say num1 and num2 at our curly braces, and then we had a return statement. Now we will compare these numbers, so I can say num1 and I can say greater than or equal to num2, in which case we want to return the maximum value, which would be num1, or num2. So I'm utilizing a ternary operator here. So I'll test it. Say I'll console.log of maxNum, and I'll say 2 and 1. So we expect 2 to be logged to the console. So execute it, and the maximum value is displayed. Implement a function to accept a number as a parameter, then return the string FizzBuzz if that number is divisible by 3 and 5, or return the string fizz if it's only divisible by 3 and not 5, or return the string buzz if it's only divisible by 5. Now if the number is not divisible by 3 or 5, then just return the original number. The next exercise is a common problem asked to junior developers to weed out candidates that don't understand the fundamentals of programming. So I will discuss the problem. So the problem is known as FizzBuzz. So it takes in a number, and if the number is divisible by 3 and 5, then you want to return the string FizzBuzz. Now if the number is divisible by 3, but not divisible by 5, then you want to return fizz. If the number is divisible by 5 and not divisible by 3, then you want to return buzz. Otherwise, you want to return the original input. So now that you've tried to implement this problem, I will go through and implement the solution for you. First, we want to use the keyword function. We'll name it FizzBuzz, and it takes in a parameter being a number. So I'll call it number. We have our curly braces. So now we want to see if the number is divisible by 3 and 5. So we have a conditional statement. We have if the number is divisible by 3, right? So we use the modulo operator. If the remainder of that division is 0, and if the number is divisible by 5, then in that case we want to return FizzBuzz. I'll do single quotes. FizzBuzz. Else if the number is divisible by 3, then in that case we want to return fizz. Otherwise, if the number is divisible by 5, then we will return buzz. In the default case, we will simply return the number input. So, go to console.log, FizzBuzz, and I'll test all conditions. So, first we'll do a value that is divisible by 3 and 5. We can do 15. So we'll log that out. So we're expecting FizzBuzz to be the result. And we get the expected result. So now we'll say if it's 9, then we expect fizz. Now in the case when it's 10, then we expect buzz. And let's say if it's 7, then we expect 7. So for the next exercise, I want you to create a function that takes in an array as a parameter and iterates through all the elements of the array, displaying all of the even numbers. So let's implement our function. We'll call it function, and I'll call it display even numbers. And I'll just call it an array as the name of the parameter variable. So now what I want to do is utilizing a for loop. So since it's an array, I can use for, and I'll say const element, or call it number of array. Then I can check if the number is divisible by 2 by using the modulo operator. Then in that case, I'll console log it. Simply call display even numbers and invoke it, passing in an array. So I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's output it in the panel. We'll go up. And here we see only the even values are outputted. Now I can copy this. And if I were to say display odd numbers, then the only change I would need to do would be to say if this is not equal to 0 by using the not equal operator. So in this case, if I were to do display odd numbers, then only the odd numbers would be displayed. So I can go up, and only the odd values are logged to the console. Control flow refers to the order in which individual statements or function calls are executed in a program. It determines the logical progression of a program based on conditions or loops, guiding the program to make decisions or repeat operations. So in this section, we covered if and else if statements to conditionally determine which code to write. So if a condition is true, then execute the code within the specified code block within the curly braces. We also have switch case statements to determine which code to execute based on equality. We covered the traditional for loop, while loops, do while loops, the potential problem of infinite loops, which we want to avoid. We covered for in loops for iterating over the keys of a JavaScript object. We covered the for of loop for iterating over an array. We also have the break statement to terminate a loop or a switch case statement, and the continue statement, which skips the current iteration and moves on to the next iteration of a loop. Great job on completing this section, and with practice, all of the syntax will become second nature. So you know that objects are a way to store key-value pairs. They allow us to group together state and behavior that's highly related. The benefit is that we can group together highly related variables and even group functions within it. So using the object literal syntax, I'll say const dog. Our curly braces creates an object literal. Now I can add a key, so I'll say name with the value max. I'll say breed, which is dachshund. Age, say 5. Weight in pounds, which is 12. So far, we've only stored key-value pairs representing properties, but we can also add our own functions. Let's say eat, and we'll say a function. So this is an anonymous function here, and I'll say console.log chomp. So that's one way of adding a function. Now there's another syntax. We can just add the name of the method, console.log. And so when we have a function within an object, we call it a method. So here we are encapsulating state and behavior. So encapsulation involves grouping together data and the methods that manipulate the data into a single unit, while hiding or abstracting away the internal details from outside interference or misuse. What is the purpose of JavaScript objects? JavaScript objects store key-value pairs. Their purpose is to store state and behavior. State is represented by properties, and behavior is represented by functions within the object. When we specify a function within an object, we call it a method. So if we were to create another object with the same properties and methods as the dog object, we would have to copy and paste. So I'll show you an example of that. Let's say I copy all this and paste it here, and let's say I call it another dog, and the name, let's give it a name of Marley. Let's say the breed is a chocolate lab. The age, let's say, is 3. And let's say the weight in pounds is 60. So this leads to code duplication, which becomes hard to maintain once our application begins to grow. So I'm going to comment this out. So far, we've been using functions to perform some operation and return a primitive value, that value being a number, a string, or a Boolean value. But we can also use functions to return an object. So here's an example of how we can do that to reduce our code duplication and our need to copy and paste. Create a new function, and I'll call it getDog. Now I'll specify parameters, which allow me to customize the properties for a dog object. So I'll call it name, the breed, the age, and the weight in pounds. So what I'll do here is I'll return an object literal with the same properties as this dog object. So I'll give it a name, So the key is name, and the value is the parameter variable, right? The argument that we pass in. We'll have the breed, we'll have the age, the weight in pounds, and then the same methods. So you can use other syntax actually, just to clean it up. Console.log, and the last method, log. So we have now created a function where by passing in the arguments to these parameter variables will allow us to get a dog object. So if we wanted to create this exact object, I can say, I'll move back up, const, I'll call it another dog, equals get dog. We'll pass in the name, Marley, the breed, chocolate lab, age, 3, and 60. So rather than having to duplicate all this code and copy and paste it, we can instead get that same functionality all in one line by using a reusable function. One more thing I want to show, we see that we do have duplication here in our function because we are using the same key and value which have the same exact name. So when you have this in JavaScript, we have syntactic sugar which allows us to clean up our code. So JavaScript is able to look at this and know that the key and the value have the same name. So this only works when these values, the key and this parameter variable that we're supplying to it, is the same. So let's output it out. Console.log, we'll call it another dog. So outputting that object, I will do node objects.js, and I can output and see the properties and the method. What are factory functions? Factory functions provide an efficient way for us to create a new object. Now, the name of the function will use camel case notation, and it can accept parameter variables. These parameter variables can help customize the values of the object being returned. The benefit is that it reduces code duplication and the need to copy and paste. So we know that the object literal syntax using curly braces creates one object, and that we can use factory functions to easily create multiple objects. Factory functions is not the common way of achieving this, rather we use constructor functions. The purpose of the constructor function is to construct the initial state of an object. When creating a constructor function, we use Pascal notation, whereas we would use camel case notation for variables and function names. Constructor functions use a special keyword called this, which references the object that's calling this code. So when you see the keyword this, you can think of it as this current object. So the naming convention for constructor functions is to have the name of it be a noun rather than a verb. So I'll show an example of a constructor function. We use the function keyword and we name it a noun. So I'll name it dog. I'll specify the parameter variables. So name, breed, age, and weight in pounds. So if I compare the differences, above we have the factory function, which uses a verb and camel case notation, and on the bottom we use a noun and Pascal notation. So internally, when using a constructor function, there's a special keyword called this, which is assigned to an object literal, the curly braces. And this is done internally and implicitly. So we don't have to explicitly write this out. I just want to show you a visual example of it. And then we would add properties to this keyword. So I'll say this.name is equal to name. This.breed is equal to breed. This.age is age. And this.weight in pounds is weight in pounds. So what we were doing, we were assigning this current object, specifying a key, and assigning it to a value. With this value is actually the argument being passed. Then we can specify our methods. I'll do this.e and assign it to an anonymous function, the function keyword. And then I'll just copy this console log. And then our last method, do this.bark, is assigned to an anonymous function. And I'll just copy this console log. And this will implicitly return the this keyword, where this keyword represents this current object. So this convention of making an uppercase and using Pascal notation tells other programmers that this is a constructor function, and it's a common convention used in JavaScript. So to use a constructor function, we utilize a special keyword called new. I'll scroll down and show an example of that. I'll say const another dog as the name of the variable, and I'll assign that to new dog. Then we pass in our arguments. I'll specify Marley as the name of the dog. It's a lab. We'll say 3 years old and 60 pounds. So we say that we instantiated a new dog object, and the variable name, another dog, references this new object that we just created, that we just instantiated. So let's talk more about the new keyword. The new keyword is syntactic sugar, which means it provides a modern and clean syntax and does 3 things under the hood. When we use the new keyword with the constructor function, it creates an empty JavaScript object. It then sets to this keyword to point to this empty object in memory, and then it returns this keyword and does so implicitly. So to recap, the main purpose of constructor functions is to define a function that will initialize an object with an initial state. And this initial state can be customized based on the arguments that you pass to the parameter variables. So now I'll log out this object. I'll say console.log, another dog, and I'll run this. And here we see it outputs our object. What are constructor functions? Constructor functions are used to instantiate objects in JavaScript. We would name the function using Pascal notation and use a noun for the name. Then for setting the key value pairs, we will use the this keyword. And within it, we can set the properties and the methods of an object. Objects in JavaScript are dynamic, meaning that we can add or remove properties or methods at any time. So for example, if we have const person is assigned to the object literal, the key of name and the value of Stephen, ended with a semicolon. Here I'll just console log that, run it again. So we just see the object literal with the expected property. Now we can also add properties on the fly. So if I do person, and let's say if I use dot notation, and I can just say any key that I want, I can say favorite food, and assign that to the string, tacos. Then I'll just copy this and I'll log it again. And this I'll comment the first console log out. And let's run it again. So here we see we have added this property of favorite food on the fly, so you can update objects dynamically. We could also update it using bracket notation. Say person, and I'll say favorite ice cream, and I'll assign that to chocolate, just to show a different syntax for you to add a property. Here, I'll log it out, comment this one out, and here we see we've added that property. Now we can also delete properties, and I would delete properties using the delete keyword. So I'll say delete person dot favorite ice cream. And then if I were to console log it, I'll just copy and paste it here. Then I expect the object to have the properties of the name and the favorite food. And we get it as expected. So I'll comment this console log. Now we could also add methods on the fly. So I can say person.eat as the key. It's just assigned it to an anonymous function. And this will just console log, say start eating, for example. Then I can invoke it. I can just say person.eat. Then the parentheses to invoke and call that method. Let's run it. And we get the expected output of start eating, which we defined in this function. So notice that when we created this object literal, we use the const keyword. Now in this instance, since we are assigning it to a complex data type, being an object data type that stores multiple key value pairs, using the const keyword means that we cannot assign it to another value, but we can still change and mutate the properties and methods within that object literal. To show an example of that, I can say person and assign that to an empty object, an object literal, and let's run it. And here we get an error because we cannot change the assignment to a constant variable after we've already initialized it. Explain in your own words, how are objects dynamic? Objects in JavaScript are dynamic because you can change and mutate the properties and methods of the object after it has been initialized. Every object in JavaScript has a constructor. The constructor function is the one used to construct an object, and it is called implicitly whenever we create a new object. We use the term instantiate whenever we create a new object, as in we instantiated a new object. So we have our existing object with object literal syntax, and person references this object. Now there is a built-in property for all objects called constructor, which we can access either through dot notation or bracket notation. So I'll console log that, console.log, say person.constructor. We'll output it. And here we see it references a constructor function. I'll comment both these out. So when we do let new object and assign it to an empty object literal with these curly braces, internally JavaScript sees this as if we were to do let new object assigned to the new keyword and then object. Comment this out. So these two lines, the one above and the one beneath it, mean the same thing. However, this first syntax, which uses the object literal syntax, is syntactic sugar. Essentially, this means it's a shorter way to write the same code. So in JavaScript, we also have new string, as in the string object, but instead we use string literals. So for example, if I did my name, now we also have new boolean, but we use true and false instead for boolean literals. We also have new number, but we just use numbers as a number literal. So every object has a constructor property, which refers to the constructor function used to create that object. What is the constructor property? The constructor property is a property that exists for all objects in JavaScript. You can access it with either the dot notation or bracket notation, and it references the constructor function used to instantiate and create that object. In JavaScript, unlike other programming languages, functions are objects. So for this function that I'll define here, I'll name it function add, and it'll accept two parameters, num1 and num2, and then I'll just return the sum of these values. So this function here is actually an object in JavaScript, so it is an object in memory. And I'll show you an example of that. I can actually assign it to another value. So I'll say const n, just the name of this variable, and I'll assign that to the name of this function. So now n references this object in memory. It references this function. I can actually call and invoke this function. And I'll show you an example of that. I'll do console.log and I'll say n and I'll invoke it and I'll pass in two arguments. I'll just say 2 and 2. Now I'll log it out, up arrow, and here you see the value 4 as expected. So I'll comment this out. So this function that I defined, add, has members, meaning that it has properties and methods. Here I'll console log and I'll say add, and this has a property length, which defines the number of parameters that this function accepts. I'll log that out and I expect 2. And we get it as expected. So I'll comment all this out and I will define a constructor function. I'll say function and then using Pascal notation. So the first letter is capitalized. I'll name it programmer and it will accept one parameter. I'll just say name. So we know to use the this keyword, which means this current object. So I'll say this.name and I'll assign it. And I'll also define a method within this constructor function. I'll say this.writesCode or write code is assigned to an anonymous function. And I'll say console.log and I'll say code in JavaScript. End it with a semicolon. So this constructor function is an object in memory. I can console.log and I'll say programmer.length. And we log it out and we see it accepts one parameter. I'll just copy one more time and I'll say constructor. Log that out. So here this references the constructor function. I'll show you a different syntax just to further demonstrate how functions are objects in JavaScript. I'll comment this out, command / or control / if you're on Windows, and I'll say const programmer and assign it to new function. I'll specify my parameter, name it name, and then I'll use backticks as the second argument, and I'll define this.name is assigned to name, and this.writeCode is assigned to the anonymous function. I'll just copy this console log here. So here I see I'm using the new function syntax to instantiate a function object, assigning it to this value. So then I can instantiate it, say const new programmer. Then I'll use the new keyword to call the constructor function, say new programmer, and pass in the argument of my name, end it with a semicolon, and then I'll say new programmer, and I'll call the method writeCode. So let's log that out, and we get the output as expected. Explain how functions are objects in JavaScript. Internally, functions are represented as objects in JavaScript, meaning that they have properties and methods. So you know that we have 8 different data types in JavaScript, which include the primitive data types, which are number, string, boolean, null, undefined, symbol, and big int. We also have the complex data type, better known as object data types. So arrays and functions also fall into the object category. The reason we differentiate these data types is because of how they're allocated in memory. So let's consider the primitive data type first. If I say let A, and I initialize that to 10, and let's say let B, and I initialize that to be assigned to the variable A. Now if I reassign the value A, let's say if I assign that to the value 20, let's console log both of them, and console.log B, open up the panel, and we'll run it. So here we see they output different values. So both A and B are assigned to a number, which is a primitive data type. And when we log them out, we see that they are 2 independent variables, meaning that they refer to different memory addresses. When we assign a variable to another variable, which holds a primitive value, then that primitive value will be passed by copy. So essentially this would be the same as doing let B assigned to the value of 10. So if this is your first time being introduced to this concept, this may seem overwhelming at first, but this will become second nature over time. To summarize what I've been saying, just remember this. Primitive values are passed by copy, not by reference. So I'll clear this. So let's say if I initialize let A is assigned to the object literal, which has the property value 20, and I'll say let B is assigned to A. So B is assigned to this reference variable, which is assigned to this object. So let me change this value. So I'll say A.value, and I'll assign that to the value 100. So now let's output both of them. So I say console.log, I say A, and console.log B. Let's see it in the panel. So here you see when I log them out, they have the same value. I updated the value of A, but I did not update the value of B. And the reason why they outputted the same value is because they are both referencing the same object in memory. They're both referencing the same memory address. So to summarize, primitives are copied by their value and objects are copied by their reference. This is an important concept and it'll make more sense with practice. And this concept also applies to other programming languages. What are primitive values and what do they pass by? Primitive values refer to simple values, such as string, number, booleans, and they are passed by copy. What are object values and what do they pass by? Object values refers to key value pairs. This also includes arrays, and they are passed by reference. So we've covered the different for loops. We've covered the for of loop, which is used to iterate over an array. We have the for in loop, which is used to iterate over the keys of an object. And I'll give you a reminder of both of those. So first I'll say let numbers, and assign that to an array of 1, 2, 3, 4, and 5. And to iterate over it, I'll use for. I'll say const elements of numbers. Now once again, I could name this variable whatever I want, but I'm naming elements just to demonstrate that it iterates over the elements of the array. Then I'll do console.log of elements. Let's log that out with node objects.js, and this outputs all the elements in the array. So I can comment this out. Then I'll create an object, say const dog is assigned to the curly braces, name, max, I'll say age is 5, and I'll say eye color is blue. I'll end it with a semicolon. Then I'll say for const key in dog. So the for in loop will iterate over the keys of an object. So I'll say console.log dog, and using square bracket notation, I'll use the key to iterate the values. Let's output it. And we get the expected result. Comment this out. So we have another syntax for enumerating over the keys and the values of an object. I'll store the values here. I'll say const, and I'll name it keys. And we can use object.keys and pass in the name of the object. In this case, it's dog. So object is a built-in class in JavaScript, and it has properties and methods. Once again, methods are just functions defined within an object. So this returns all the keys of the object as an array. I'll console log it, console.log keys. So this outputs all the keys of the object. Comment this out. Now we also have object.values in order to get all these values stored as an array. So I can say const values is equal to object.values of dog. Let's console.log that and output it. Now we get all of the values of this object stored as an array. We could also get the properties, so the key value pairs, each stored as an element in the array. To show you that, I'll say const, and I'll call it entries equal to object.entries and pass in the name of that object. Let's console log that. Entries. And we'll output it. So here we see the key value pairs has been stored as an element in the array. So essentially this is a nested array. So this provides another syntax to accomplish the same thing, which is enumerating over an object. Now to show you how we can use these methods to iterate over the values, I'll show you an example. Let's say for, and I will say const key of object.keys. I pass in dog. I'm using for of because we are iterating over an array. Then I can just copy and paste this to key. We'll output that. So once again, this iterates over the array. And comment that out. Then I'll say for const value of object.values, the name of the object, and let's output that. This outputs all the values, and then we'll do our entries. So I can say for const entry of object.entries, pass in the name of the object, console.log of entry, and we'll output it. So here we see the key value pairs displayed as an array. And this particular syntax may come in handy when doing programming interviews during cases when you need to enumerate over an object. How can you enumerate over the properties of an object? There are different ways to enumerate over the properties of an object. One way is you can use the for in loop to iterate over the keys of an object. We can also use the built-in object class. For example, iterating over the keys with object.keys, enumerating over the values with object.values, and enumerating over the properties with object.entries. So we know that if we have two variables, I'll say let A is assigned to the object literal, value of 10, and I'll say let B is assigned to A. Now if I were to update one of the variables, we know that since they both reference the same object, if I change one, it will also affect the other variable. So do console.log A and console.log B, And since they both reference the same object, they will both have a value of 20. So I'll run in the panel. So here they display the same value as they both reference the same object. Now, if we wanted to have it the case where if we change the value of one of these variables, it doesn't affect the other, then we would need to have it be two independent variables. And that could be accomplished by creating a clone of an object. So we know that objects are passed by reference. So we need to use a built-in method called object.assign. So instead of saying let B is assigned to A, I'll initialize it to an object literal. Then before I assign this value, I will do object.assign. First, I will pass the target object. This is the object that I want to copy to. So in this case, it would be B. And then I will provide one or more source objects in which I want to copy the properties and methods to the target object. In this case, it is the variable A. So all the properties and methods of A will be copied to B. And it will create two independent variables. So B will now have a clone of the object that A references. So here I'll save this and I'll run it. So here you see they reference two different objects and they have different values. Changing one does not affect the other. Now we also have another syntax that allows us to accomplish this, known as the spread operator. It uses 3 dots as in an ellipsis, and this will create a copy of the object. So instead of having to do object.assign, when I initialize B, I can use 3 dots, ... and then the object that I want to clone. In this case, it'd be A. So this will create two independent objects, so they are not referencing the same object in memory. Open up the panel, and we'll get the same result. How would you make a clone of an object? In JavaScript, you can make a clone of an object by using object.assign. For the first argument, you would pass the target object. Then you can pass in one or more source objects. You can also use a more modern syntax known as the spread operator in order to copy the properties and methods to a target object by the use of 3 dots before the variable that references the object. In programming languages like C++, when you create an object, you have to allocate memory and deallocate it. But in programming languages such as JavaScript, C#, and Java, we don't have this concept, so you don't have to explicitly deallocate memory. The JavaScript engine has a garbage collector, meaning that it will self-manage itself and find the variables and objects that are no longer being used in our program, and it will intelligently free up that memory. As JavaScript developers, we don't have to worry about allocating and deallocating memory for our objects. In JavaScript, we have a built-in class called math. This has static helper methods to help us do mathematical calculations and is often utilized in programming interviews. It has many methods, so don't worry about memorizing it. Rather, refer to developer.mozilla.org. Search for math and click the first recommendation. Then you can read the documentation and view the various methods that it contains. Here I will show you the most commonly used ones. I'll open up the panel and I'll type in node. So when working with decimal numbers, I can use math.round and pass in 3.14. And this will round the number. Likewise, if I did math.round, say 3.6, and it will round up. Now, if I always want to round down, I can use math.floor. Let's say 4.6. If I always want to round up, I can do math.ceiling. Say I do 4.2. Now, to find the maximum number, I can do math.max, and I can pass in 1 and 2. I could also add in more arguments. Let's say if I 1, 2, 3, 4, and 5. So it accepts more than just 2 arguments. Likewise, I have math.min. So say if I do 1, 2, and 3. We could also raise to the power of. So I can say math.pow. The base number, let's say if I make it 2. And let's just say if it's cubed, then I can perform that. I can do math.square root, say 25. So I'll clear this out. Now, one of the most useful built-in methods is the random method. We can do math.random. So this will return a number between 0 and 1 as a decimal value. Now, if I want to return a random number between a range, then I would need to perform it differently. Let's say if I do let.min, assign that to 1, and I say let max equal to 10. Now, if I want to return a random number, I can say const random number. Then I'll assign that to math.random times the max minus the min plus the minimum. So this will return a number between 1 and 10. And if I want it to always be an integer value, then I would do math.round and wrap it in parentheses. So I'll console log this value, console.log, random num, and this will generate a random number between that range. If I just run node objects.js, if I run it again. So don't worry about memorizing these will come second nature over time. I just wanted to introduce you to the built-in methods that you have access to. What are some of the methods that the built-in math class has? Some of the methods that we covered include math.floor, math.round, math.ceil, math.max, math.min, math.square-root, math.power, and math.random. How would you generate a random number between 1 and 100? This line of code represents the formula in order to create a random number between a minimum number and a maximum number. So in JavaScript, we have two kinds of strings. One way is the string literal through the use of single quotes, double quotes, or backticks. So for example, if I just do const name is assigned to a name, I'll console log, I'll say type of name. When I output it, I'll see that it is a string data type. Now I can also make a string using the string object. So I can say const, I'll call it another name, assign that to, with the new keyword, which calls the constructor of string. I can pass an argument. Here I'll just say Joe as the name. Now if I console log the type, I'll see that it is an object. Another name, I'll put it, and we see this value is an object data type. So I'll comment this out. So with this variable that is assigned to this string literal, we can access the methods of strings using dot notation or bracket notation. And the JavaScript engine will internally wrap that string literal with the string object. So there are built-in methods that allow us to operate and manipulate strings. In this video, I'll show you some of the most commonly used ones. I'll make a new string. I'll say let sentence, and I'll assign that to a new sentence. And I'll end it with a period. Comment this out. Now I can check does include new, for example. I can say sentence, and one built-in method is includes. Pass in the string new, and so what this does is this checks the string and sees if the string passed to it as an argument is found. If it is, then it returns true, otherwise it returns false. Here I'll just log it out. Does include new. Here we see that it does include. We can access characters by index value, where the first character of a string is at the index of 0, the second character is at the index of 1, third character is index 2, and so on. So if I do console.log of sentence at the index of 3, so if we count this, we see the first character at the 0 position is A, then the empty string, then N is at the second index, and then E is at the third index, because we start counting from 0. So we're expecting E, we'll show it in the panel, and we get the character that we expected. Comment this out. I can say const starts with A, and I'll say sentence. So the method is starts with, and I'll pass in the string of A. And this will return true if the sentence begins with this character, and false otherwise. Console.log starts with A, and we see that it's true. Now I'll just copy this, paste it here, and I'll rename it. I'll say ends with A, and change the method to be ends with. Change that here, comment it out. So we expect this to be false. I'll run it, and we get false as expected. Now another useful method is the replace method. So if I do let updated sentence.replace, the first argument, I can specify the string that I want to replace in the current existing string that I'm operating on. So let's say new, and I want to replace that to be short. So this will return a new sentence, and it will not mutate this existing sentence. Let's output it. Console.log, updated sentence, output it. So we're expecting the new string to be a short sentence, and we get that updated string. Now some other useful methods is the trim method. So if you're expecting user input from an input field, it is useful to use the trim method in case the user has spaces in the beginning or at the end of their input. So let's update this as if we had space in the beginning and space at the end. I'll call this trimmed sentence. So I can say sentence.trim, and this will remove the spaces from both the beginning and the end. Here, I'll just console log it. And we get that string with the spaces trimmed at the end. Now some of the methods is trim left, which will remove the spaces from the beginning of the string. And we have trim right, which will remove spaces at the end. One useful method that is commonly used in programming interviews is the split method. With the split method, we can specify a delimiter, and what JavaScript will do is that it will create an array, splitting the sentence. So I can say const, and I'll say words in sentence. Then I will say sentence.split, and the delimiter I'll say is an empty string. So this will split the string whenever it encounters an empty space, when those elements will be placed in an array. Here I'll remove these spaces in the beginning and the end. So here let's console log it. Console.log words in sentence. Then I'll output it. So it is split based on the white space. So I'll comment this out. Two other helpful methods are to lowercase and to uppercase. So let's say a user enters in their email. And they enter it with mixed casing. So some letters are capitalized, some are lowercase. Well, when we save that email in the database, we likely want to make that all lowercase or all uppercase, so that next time when the user logs in, they are not restricted from logging in based on case sensitivity. So I can say let lowercase email, assign that to email, and I'll say to lowercase. Let's console log that. Lowercase email, node objects.js, and we get that same string, but in all lowercase. Likewise, I can say let uppercase email, assign that to email.toUppercase, output it, uppercase email. And now we get it in all uppercase. There are many more methods available for strings, and it's best to consult developer.mozilla.org to view the documentation for strings. Name some of the methods in the string class. Some of the methods in the string class that we covered in this lesson is replace, trim, trim left, trim right, includes, index of, split, to lowercase, and to uppercase. In previous lessons, when working with strings, we have used either single quotes or double quotes. We have another way to create a string literal, and that is with backticks. So the backtick key on your keyboard is usually above the caps lock key on the upper left side. The benefit of using backtick characters, which we call a template literal, is that it allows us to use string interpolation rather than having to use string concatenation. So for example, if I say let first name and assign that to my name, and then I say let last name and assign that to my last name. Now if I want to combine them, I can say I'll say full name, and I would have to do first name and use the plus sign operator, add last name, and this performs string concatenation, creating a new string and storing it in this variable. So let's output it, console.log, full name, and when we run it, we see the strings have been combined, but there is no space between them. So let me add that in. I'll add an empty space, and then another plus sign. Now if I run it again, I see it properly displays with the space in between. So rather than having to include this, which is a bit hard to read, I have another syntax that I could use. So I'll comment this out. With template literals, it provides a cleaner syntax to accomplish the same thing. I can say let full name, then I'll use backticks to create that string literal, otherwise known as a template literal. Then I can use a syntax, a $sign, and then curly braces. This acts as a placeholder, and within the curly braces, I can specify an expression. In this case, I will use the variable first name, then a space, then $sign, and then last name. Now I'll output it, and I get the same result. What are template literals? Template literals provide an alternative syntax to the traditional strings by using backticks. The benefit is it enables us to use string interpolation, meaning that with the $sign and then curly braces, we can utilize that as a placeholder and specify expressions within it, rather than having to use concatenation with the plus operator. In JavaScript, we have a built-in date object. It stores the date and time. It also provides methods for data and time management. In JavaScript, we would use the date object most commonly to store creation and modification times for a resource. The date object can be initialized in multiple ways. I'll open up the panel, type in node, and then enter. Now we can initialize a date object by going new, then date, and if I pass in no arguments, then this will create a date object based on the current date and time. Do now, and enter. This shows my current date and time. Now you could also create a date object by passing in a number, which will represent the number of milliseconds since January 1st, 1970. So for example, I can say let January 1st of 1970 equal to new date. And if I pass in 0, representing 0 seconds since January 1st, 1970, then when I log that out, then it displays the date and time. Likewise, if I were to do let December 31st, 1969 assigned to new date, and if I do -24 times 3600 times 1000, then this would be the previous day. You could also pass in a date string to construct a date object by just do const, we'll say date1, assigned to new date. If I pass in December 25th, 2024, and specify a time, I can log that out. Now I can do January 1st of this year, and I can say new date, passing in the year, then the month, which is indexed at 0. So 0 would represent January, then the 1st. When I log that out. So check out developer.mozilla.org to read the documentation on the date object. There are many methods built in that can't be feasibly covered in one video. Now to cover some of the most common methods, I'll clear this out. Now if I have now assigned to new date, One method we could use is now.getFullYear. We have now.getMonth, represented as a number, and now.getDate. We also have now.getTimeZoneOffset. So this will return the difference between coordinated universal time and your local time zone in minutes. This video was just meant to provide an introduction to the date object and to give you an idea of all that this object can do. So in this section, we covered object literals, factory functions using camel case notation to create a new function. We covered constructor functions, which uses Pascal notation, and we can instantiate objects using the new keyword with these constructor functions. Constructor functions utilize the keyword this, which refers to this current object, and it implicitly returns a new object. We covered the dynamic nature of JavaScript objects and how we can add properties or delete properties on the fly. We covered that functions are objects in JavaScript and they have properties. Note that primitive value types are passed by copy, and object types are passed by reference. You can clone an object with object.assign or use the more modern syntax, which is the spread operator, represented by 3 dots. We went over template literals and how we can use string interpolation, and we briefly covered methods built into the string class and date class. So great job completing this section. We covered a lot of material, and I will see you in the next one. Arrays are a commonly used data structure, which provides a collection of elements, in other words, a list of items. In JavaScript, each index position, known as an element, can be of any data type. However, in real applications, all the elements of an array are usually of the same data type. There are many built-in methods for arrays, which enable you to modify, filter data, and retrieve data using clean and modern syntax. In this section, we'll dive into some of the most commonly used methods. What is an array? An array is a commonly used data structure in JavaScript that stores a list of data. So one of the most common operations when dealing with arrays is adding elements. So I'll rename my file to be arrays.js. Then I'll declare an array. I'll say const, call it numbers, square brackets, and I'll say 5, 4, 3, 2, and 1. So since we have used the const keyword, we can't reassign this array to any other value. So the numbers variable references the array in memory, and an array is an object, meaning it contains key value pairs, in this case mapping an index value which starts at 0, going from 0, 1, 2, 3, and 4, and that maps and corresponds to this element value. So the const keyword means we can't reassign it, but we can modify the array. So for adding elements to this array, there are 3 scenarios or 3 ways that we can add an element to it. We can add to the end, we can add to the beginning, and we can add to the middle. So to add a value to the end, you would use the push method. So I can say numbers .push, and I'll pass in the value 7, and let's console log it. Then I'll say node arrays.js, and here we see the array outputted, and the element that I pushed was added to the end of the array. So the push method can accept multiple arguments, so we can add multiple values at once in one go. So let's say I want to add 7, 8, and 9. Let's save it, and we'll log that out. And here we see it has added all those values to the end. Let's comment this out. We can also add a value to the front of the array, and we would use the method unshift. So I'll say numbers.unshift, and I will say 25. So I'll just copy this console log, and I'll paste it here, once again in the console. And we see the value 25 has been added in the beginning of the array. We can also do multiple values at once. Let's say 25 and 24. And both those values have been added to the beginning of our array. Comment it out again. Next, we want to consider adding elements to the middle of an array. And to do that, you would use the splice method. So the splice method for adding elements uses 3 arguments. I can say numbers.splice. For the first argument, you would specify the index position where you want to start from. In this case, I'll say from the first index position. So this will be the index position just after the value 5. For the second argument, you would specify a number which indicates the number of elements that you want to delete. Since I don't want to delete any elements in this example, I will use the value 0. Now for the third argument is where you would specify what data you want to add. And you could add more than one value. In this case, I'll say I want to add the values 25 and 24. And then I'll console log it, opening up the panel. I go up and run it. Here I see the values 25 and 24 have been added, starting from the first index position of the array. How would you add an element to the beginning of an array? You would use the method unshift to add to the beginning of the array. How would you add to the middle of an array? You would use the splice method. How would you add an element to the end of an array? You would use the push method. Arrays can store both primitive data types or reference data types, meaning objects. There are three main methods that we can use to check if an array contains a primitive value, and that is .indexOf, .lastIndexOf, and .includes. Let's go over an example of each. Let's say if we initialize the array numbers is assigned to 5, 4, 3, 2, and 1. Now, if we want to find the index of the value of 3, I can say const index of 3 and assign that to numbers.indexOf, and then the value I want to search for. So this will return the index that it's found at, starting from left to right. Now, if this value that I pass as an argument is not found in the array, then it will return the value -1. So I can output that, and I'm expecting the value of 2. So I can say console.log of index of 3. Now if I output that in the console, and here I see the value of 2, indicating the index that it's found at. Now typically I wouldn't just output the index value, rather I would use it with bracket notation. So I can say numbers, and then in bracket notation, then I would utilize that variable. So I can access this value by index. Comment this out. Now, let's say that if we had a duplicate value, so if I add 3 at the end, indexOf always searches from left to right. So if I wanted to find out what is the last index of it, then I can use the last index of. So const last index of 3, assigned to numbers.lastIndexOf, that same value. So we're expecting last index of 3 to be 5, because we count from 0, 1, 2, 3, 4, and 5. That is the index position. So let's just output that. Console.log last index of 3. And we get the value of 5 as the index where it is stored at. Now let's try a case when we search for a value that does not exist. We can say const index of 10 and assign that to numbers.lastIndexOf 10. So this will have the value of -1. And if we try to access that by bracket notation, then we would get the value of undefined. So let's output both of those, console.log. So this will output -1. And then when we try accessing it, then we will get numbers index of 10, and this will be undefined. Let's see that. And we get that output. Now, whenever we use .indexOf or .lastIndexOf, we typically do a conditional statement and check and ensure that the value is not -1 before using it to access that element. So I can comment both that out. And then I can do, for example, if index of 10 is equal to -1, indicating that the value of 10 is not found in the array, then I can console log 10 is not found in the array. I can output that. So we can utilize .indexOf and .lastIndexOf with our conditional statements. Now, if we are not utilizing that index value in order to access or change that element, then we can just use the includes method, which will return a Boolean value of true or false, depending on if that value is found in the array. So I can say if numbers.includes 10, then I can say console.log 10 is found in the array. And so since 10 is not found in the array, this will not be console log. Let's see if I log it out. And there is no output. Now, I could use the exclamation point in the beginning. So with the exclamation point, this reads, if the numbers array does not include the value 10, then output what is in the code block. So I can say 10 is not found in the array. And when I run in the console, I see that output. How would you check if an array contains a primitive value? There are three main methods you can use. You can use .indexOf, .lastIndexOf, or .includes. Consider the following array. Employees, we'll assign it to an array of objects. We'll say the ID, name, Jim. So then I'll add 2 more objects to this array. I'll copy this, and then I'll do Shift, Option, and down arrow 2 more times. Then I'll update the IDs, 2 and 3, and update the names. I'll say Michael Scott and Pam. So with this array of objects, using the includes method or indexOf won't help us find an element, as comparing 2 different objects, even if they have the same properties, won't be equal, as those objects have different memory addresses. So instead you would use the find method. I'm going to find that here. Say const employee equal to employees.find. Now as the argument, you would pass a function. In this context, the function will be referred to as a callback function. We call it a callback function because we pass the function as an argument and it will be invoked at a later time. Now this particular type of callback function for the find method is referred to as a predicate function, meaning that it will return true or false. Previously I mentioned that functions are objects, so this is what enables us to pass functions around as arguments in JavaScript. So we can specify function, we will define an anonymous function, so we won't give it a name. Now it will accept an argument. We'll specify e as the parameter variable. Then we can do curly braces. and end it with a semicolon. Now within the code block, the predicate function has to return a true or false value. So we can do return, then the parameter variable e.name equal to, and we'll say Jim. So if this value is not found, then it will return undefined. Otherwise, it will return that element. So I can console log it, console.log, employee, opening up the panel. Here you can see it outputs that object. So the find method will return the first element that matches. We also have the find index method, which acts the same way, except instead of returning the object, it will return the index where that object is found at. What array methods would you use to find and locate an object? You can use the find method or find index method. For both of them, you would specify a predicate function to locate an object based on a property. So previously we used an anonymous function in order to define our callback function. However, there is another more modern syntax that is more commonly used and is easier to read. This syntax is known as an arrow function. So traditional functions will look like write a function, add, and I specify two parameters, num1 and num2, curly braces, and then I just return num1 plus num2. So this is known as function declaration. Now another syntax to accomplish the same thing is the arrow function. So I can name it const. I'll comment this out. Then I'll name it add an equal sign for an assignment. And then I specify the parameter variables. So I'll say num1 and num2. And then I will use an equal sign and then the greater than sign. So this denotates an arrow. Now I would specify that same functionality in the curly braces, num1 plus num2. So remember, functions are objects in JavaScript. So this is being assigned to the add variable. Arrow function syntax is commonly used for callback functions. When you have an arrow function that has just one statement in the code block, then you can simplify it. You can remove the curly braces and put everything on one line. You could also remove the return statement because the arrow function knows implicitly that you are returning this expression. This provides a cleaner syntax to use when using predicates. So rather than using this implementation with the function declaration, we'll comment that out. And here, I can remove that function keyword, so it's no longer an anonymous function. Then I use the symbol for arrow function, and I can clean it up and put everything on one line. So I can remove this return statement and remove the curly braces. So this is a cleaner way to accomplish the same thing. How would you define a function for the .find method? The .find method is a method that exists for the array class and it is used in order to find an object. For the argument, you would specify a function. In this case, it would be a predicate function, meaning that it would result in true or false. You could use either an anonymous function or an arrow function in order to implement this. What is an arrow function? An arrow function is an alternative syntax to the function declaration syntax. You would assign it to a variable and define it with parentheses, and then use the symbol for equal sign and greater than symbol, and then specify the code block. If the code block only consists of one line, then you can put everything on one line, and you can remove the return keyword. So once again, let's create an array. I'll name it const numbers is assigned to 1, 2, 3, 4, and 5. So for adding elements to an array, we can use the push method to add to the end. We have unshift to add to the beginning, and we have splice to add to the middle. Now for removing elements, we have pop to remove from the end, we have splice to remove from the middle, and we have shift to remove from the beginning. So let me show an example of each of these. So if I do const last element assigned to numbers.pop, this will remove the last element, so in this case, the value 5 stored in this variable. So let's output that. Say console.log. Now I'll use backticks and we'll use our template literals. I'll say last element, colon, and then $, curly brace, last element, and let's output that. We're expecting the value 5. So here we see last element and then the value that was removed. If I want to remove the first element, I can say numbers.shift. So this will remove the value of 1. So let's output that. Console.log, if I say first element, and then $, first element, end it with a semicolon, we can output that, go up and run it again. So here we see the first element of the array was removed. We could also add a space between these values if I add \n. So when JavaScript encounters \n, it knows that this means to create a new line. So if I run it again, we can expect this time there would be a space between these outputs. So let's do our last method, which is the splice method. So for the splice method, it could be used to add to the middle of an array or to remove from the middle of an array. So here we do, say const, I'll name it middle element equal to numbers.splice. So for splice, the first argument is the index to start at. The second argument is the number of elements to delete, starting from the index specified in the first argument. Any argument that you pass after that is optional, and it will specify the new values to add. If I say from index 1, and I want to remove one element, this will return the value and store it in middle element. So if I do console.log middle element and output it, here I see the middle element has been outputted with the value of 3. How would you remove an element from the beginning of an array? You would use the shift method to remove an element from the beginning. How would you remove an element from the middle of an array? You would use the splice method. How would you remove an element from the end of an array? You would use the pop method. So we covered how to add elements to the numbers array, as well as how to remove elements. Now, if you wanted to clear all the elements of an array, there are different ways that we can do that. One way is we can use a while loop. We can say while numbers.length is greater than 0, then we can call numbers.pop. So repeatedly move from the end. So although this works, if the numbers array was large, this would be an inefficient way to do so. We can comment it out, and we'll look at a different way. So we've covered the numbers.length property. We could also use this property in order to assign a value. So if we assign it to 0, this will clear the numbers array. So I can output that. I'll say console.log, and I'll output this array. And there I see that the array is empty. Let's comment this out. Now we've used the splice method, which can be used for adding and removing elements. So we can say numbers.splice, starting from the first element at index 0, and then for the second argument, it specifies the number of elements to delete. So I can say numbers.length, and this will remove every element. Also, the splice method will return all the elements that were deleted in an array. So I'll just say const, I'll just say deleted numbers, and let's log that, console.log, a template variable, deleted numbers, deleted numbers. When we output that, we can see all the values that have been deleted. Let's comment this out. Now, another way we can do that is simply defining numbers to a new array. So remember, an array is an object. So when we assign it to a new array, the previous array will be garbage collected. Since I use the const keyword, that means that I cannot reassign it. So I would need to change this to let in order for me to reassign this variable. Another thing to be aware of, if I were to have another variable, let's say if I name it let another array, assign it to numbers, then both of these values will be referencing the same array in memory. So in this case, even though I reassigned numbers to an empty array, another array will still be referencing this previous array. So it will not be garbage collected. How would you empty the contents of an array? To empty an array, you can simply assign it to a new array. You could also set the length property to 0 or use the splice method. So let's say we have two arrays and we want to combine them into one array. So I can initialize const example numbers A assigned to 1, 2, and 3, then const example numbers B assigned to 4, 5, and 6. So now I can combine them using the concat method. So I can say const combined array is equal to example numbers A dot concat example numbers B. So this will return a new array, so console.log combined array, and displaying it in the panel. Here I see it has created a new array. Now we can also slice the array, meaning that we can specify a start index and an end index, and it will return a new array with the elements found within that range. The slice method will not affect the original array. So I can say const first slice assigned to combined array dot slice from 0 to 4. So opening up the panel, here since I specified the range between 0 and 4, it will return a new array containing the values of 1, 2, 3, and 4. So the second argument is exclusive. Here, if I log that out, console.log for slice. So these are the two methods to combine and slice arrays. So if you're performing this with primitive values, then the elements will be passed by copy. However, if you're dealing with objects, then the elements will be passed by reference. How would you combine two arrays? You would use the concat method to create a new array. How would you get a slice of an array? You would use the slice method, and you can pass two arguments, the start index and the end index. There is another way to combine two arrays, which is to utilize the spread operator. We have discussed the spread operator before, so it can be used to copy the properties of an object or the elements of an array. So rather than using the concat method, I can say let combined is assigned to 3 dots to spread the elements in this array, comma, and then the other array. So this accomplishes the same thing as the concat method, and this is the more commonly used syntax. I'll put in this, and we get the same result. This syntax also provides more flexibility than the concat method, as we can add elements in between these values, meaning I can put a value here, or perhaps at the end. So it provides more flexibility than the concat method. So if I remove this, and if I just say let A is assigned to 1 and 2, and then let B is assigned to A. So arrays are objects, which means that they are passed by reference. So the references of A and B both reference the same array in memory, so the same object in memory. So we could also utilize the spread operator in order to make a copy of an array. So instead of saying let B is assigned to A, I can say square brackets to create the array, and then the spread operator. So this creates a new array and spreads the contents. What is the spread operator? The spread operator refers to using 3 dots in order to copy over an object. So this could refer to an object literal and copying over the properties. It could also refer to the elements of an array. To iterate over an array, you could use the for of loop that we covered previously. So just a quick reminder, if I initialize the numbers array again, 1, 2, 3, 4, and 5, then I can do for, I can say let number of numbers, and because I'm just gonna use one line, I don't need the curly braces, just to output that. So here I see it outputted every element. Now there is another built-in method in the array class known as for each. So the argument that you would pass into the method is a callback function. So if I did numbers.forEach in camel case, then as the argument I can pass in an arrow function, specify the number, then the arrow, and the curly braces. Then I can console.log the number. So if I output that, I get the same result. Since this code block only includes one statement, I could put everything on one line to simplify it. So if an arrow function only has one parameter, then you can remove the parentheses around it, helping clean it up even more. The for each method also accepts an optional second parameter, which takes into account the index. So if I add that in, then I can utilize that when I console log it. So if I use template string, then I can say at index, specify it here, and then colon, and then I'll specify the number at that index. So if I log it out, then I can see what value is stored at each index. How would you iterate through an array? You could use the for of loop to iterate through all the elements of an array. You could also use the built-in for each method. You would pass in a function as an argument, which will take an element as a parameter, and optionally take in the index as a second parameter. To transform an array into a string, the join method can be utilized. So if I initialize the array, const numbers, assigned to 1, 2, 3, 4, and 5, I can convert that into a string. So I can say const join numbers, assigned to numbers.join. So the join method allows you to specify a separator as the argument, and this separator will be placed in between the elements. To show an example of that, it will take in a string, and I will specify a comma as a separator. Then I can console log that, console.log, join numbers, open up the panel, and I run it. And here I see this has been outputted as a string where every element is separated by commas. On the flip side, the split method is available for strings, enabling the reversal of this process by transforming a string into an array. So this will not alter the original string, rather it will return an array. So let's see if I comment this out. So if I do const course name is assigned to JavaScript for beginners, then I can split up the words in two parts, and I can say course name dot split. And as the argument, I can specify the separator as an empty string. So because I specified an empty string as the separator, what JavaScript will do is it will go from left to right, and whenever it encounters this value, the empty space, it will perform a split. So this string will be converted into an array. This word, JavaScript, will be at the 0 index of that new array. 4 will be at the first index, and beginners will be at the second index. So if I log that out, console.log parts, output it. Here I see I've converted that string into an array. So to show an example of how this can be useful, consider the term of a URL slug. So this refers to having a descriptive path in your URL, your Uniform Resource Locator. In URL slugs, words are separated by a hyphen. So in order to perform this, we can use the join method. So the sentence, JavaScript for beginners, is what we want to include in our URL. We performed a split based on whitespace and stored it in an array. Now I want to join everything together with a hyphen. So I can say const, and I'll say URL slug is assigned to parts.join, and I will specify the hyphen character. Then I can output that. Opening up the panel and running it again. Here I see it is now displaying each of the words separated by a hyphen. Now let's say we want to make every word in the sentence lowercase. So the simplest way to do that will be to use the toLowercase method in the string class. So before performing the split, I can say const, and I'll call it lowercase course name is assigned to course name dot toLowercase. Then I can utilize this variable for performing the split. So now if I output it, it now displays all the words in lowercase and separated by a hyphen. So we can clean up our code even more. Here we have course name, and it's assigned to a string. Then we call .toLowercase, assigning the value to this variable, which is a string data type. Then we call the split method to convert it into an array. We can actually clean up these two lines by utilizing something called method chaining. So I'll add some spacing to make it more readable. And I'll comment this out and show how we can do it with cleaner code. So if I do const parts and assign to course name dot toLowercase. So this is still the string data type, so I can call dot split and specify the separator. This enables us to implement the same functionality in one line. Oftentimes when we do method chaining, we would add the method calls to their own line. So I can add it on a new line and then tab, and the same thing with the split method. So when performing method chaining and calling one method after another, we often will put it on its own line. And we're able to do this because they are all the same data type, in this case the string data type. How does the join method work? The join method is available for arrays in order to convert the elements into a string. It accepts an argument where you can specify what the separator will be, and that separator will be placed in between the elements for the string that it returns. How does the split method work? The split method exists for the string data type. You specify the separator, and then it will convert the string into an array. In programming, sorting is a common operation. JavaScript arrays come with a built-in sort method that allows you to easily sort the array elements. By default, when you call sort on an array containing strings or numbers, it sorts the elements in ascending order. Let's see this in action. If I initialize this array, let characters assigned to C, D, B, and A. In order to sort these elements, we simply need to call the built-in sort method. So I can say characters.sort, and then I'll log it out. Console.log characters. And we will see it sorted in ascending order. So here if I do node arrays.js, we see the elements have been sorted. Another useful method in the array data structure is the reverse method. So this can be used to reverse the order of the elements. So rather than sort, if I say reverse, here we will see these elements updated in reverse order. So if I output that, here I see the array has been updated with the order reversed. So if I switch back to the sort method, this approach works seamlessly for arrays containing strings or numbers. However, when you have an array of objects, you need to provide a callback function to the sort method. This function defines the sorting logic based on the properties of the object in the array. So I'll clear this out, and let's consider an array of employee objects. So if I say let employees, and within it I'll specify an object with an ID of 1 and a name of Jen. Then I'll copy and I'll create 4 more elements. So if I do Shift, Option, and down arrow, creating 4 more elements, and I'll update the IDs to be 2, 3, and 4. And for the name, I'll say Stephen, then Andrew, then Terry. And I'll end it with a semicolon. So here I see these objects are ordered based on the ID. However, if I want to sort it based on the names, then I need to specify a callback function. In that callback function, I will specify 2 parameters, which represents 2 elements. In this case, 2 objects being compared. So if I do employees.sort, now I can name these parameters whatever I want. In this case, I'll just name it A and B. Then I'll specify the arrow function and the curly braces. So in our callback function, we will compare values based on one of the object's properties. So in this case, we will use the name property. The callback function returns a number that determines the sort order. Returning a negative value means the first argument, in this case A, comes before the second argument. Returning 0 means that they are considered equal and in sorted order. Returning a positive value means that the first argument, A, comes after the second. So since we will be sorting based on the name property, we will be performing a comparison based on these characters. Now characters are internally represented as numbers in computers based on their ASCII values. This means capital letters are considered less than lowercase letters. To handle case sensitivity, it's a good practice to convert strings to the same case for comparison. So let's implement our callback function. So first I'll make it all lowercase, so I can say const lowercase a is assigned to A, then the name property of that object, and then I'll call to lowercase, which is a built-in method for strings. Then I'll just copy this with Shift, Option, and down arrow, and I'll name it lowercase b, and then I'll change the object that we're using, b. Then I can perform the comparison using the comparison operators. So if I do if lowercase a is less than lowercase b, in this case we will return -1, which means that the object a will come before the object of b. So for example, if we consider the object a to be this first object, and we consider b to be the object just after it, we are comparing these 2 name properties. And because we determined Jen to come before the name Stephen, returning a negative value means that object A comes before object B. So we compare 2 elements at a time. Now in the case when if lowercase a is greater than lowercase b, then we return a positive value, which means that A comes after the object B. Otherwise, if they are equal, then we return 0. So this callback function will be used to sort the objects in our array. So now if I console log employees, I will see that they are sorted alphabetically based on the name property. So now I'll put it console.log employees, open up the panel, and we'll clear it, and then we'll run it. So here I see the objects are sorted alphabetically. How would you sort the elements of an array? You can use the built-in sort method to sort the elements of an array. You can simply invoke the sort method if the array consisted of elements that are strings or numbers. However, if the array consists of elements which are objects, then you need to specify a callback function. This callback function will accept 2 parameters representing 2 objects to compare, and you would compare those objects based on their properties. In JavaScript, arrays come equipped with several powerful methods that allow us to process and evaluate the data within them efficiently. 2 such methods are every and sum, both of which are used to test elements in an array against a condition. Let's explore how each of these methods work and when to use them. Starting with the every method. The every method tests whether all elements in an array pass the test implemented by the provided function. It returns true if every element in the array satisfies the specified condition and false otherwise. This method is perfect for scenarios when you need to ensure that an entire collection meets a certain criteria. For example, let's check if every number in an array is even. So let's instantiate an array of numbers. I'll say const numbers assigned to 2, 4, 6, 8, and 10. So I will store the result in the variable are all even, which will hold a Boolean value. This is assigned to the result of numbers.every. So when I hover over every, I see that it accepts a callback function, which is a predicate. So this callback function must return true or false, and it can accept up to 3 parameters. The first parameter is the current element of the array. The second parameter is the index of where the element is stored. And the third parameter is the original array. Of these 3 parameters, only the first one is mandatory, and the other 2 are optional. In this case, I only need the first parameter, so I'll name it number. Then I'll use the arrow function syntax, with the curly braces, and then I will return when that number, mod 2, is equal to 0, then we know that it is even. So I can console log are all even, console.log, I use my template string, are all even, colon, and then I use string interpolation, are all even, end it with a semicolon, and then we'll log this out. Up arrow, and here I see the value of true. So we know all the elements are even. So because our code block just consists of one statement, we can clean it up and put everything on one line. So here if I run it again, get the same result. Now let's consider the sum method. On the flip side, the sum method checks if at least one element in the array passes the test implemented by the provided function. It returns true as soon as one element satisfies the condition, making it useful for scenarios when you're looking for the presence of an element that meets a specific requirement. So let's instantiate an array. I'll say const numbers, assigned to 1, 3, 5, 7, 8, and 9. I will store the value in a variable has one even number, which holds the Boolean result, and then I'll say numbers.sum. So once again, this predicate callback function accepts up to 3 parameters. In this case, we only need the first one, which is the element that we're operating on, and I'll name it number. And I'll use the arrow function syntax, and I will check number mod 2 is equal to 0. Then I can log that out, console.log, template string again, has one even number, colon, and then interpolation, has one even number, ending it with a semicolon, and let's output that. So here I see the value true, because this array has the value of 8. It's important to note that both the every and sum methods operate on arrays in a way that they stop processing elements as soon as the outcome is determined. For every, it stops and returns false as soon as it encounters an element that does not meet the condition. Sum stops and returns true at the first instance of an element that satisfies the condition. These methods are incredibly useful for array processing in JavaScript, providing a concise and readable way to evaluate conditions across array elements. Whether you're checking for consistency with every or searching for possibilities with sum, these methods offer elegant solutions to common programming scenarios. What is the every method and how does it work? The every method is a built-in method in the array data structure, and it tests whether every single element in an array satisfies a specified condition. What is the sum method and how does it work? The sum method is a built-in method in the array data structure. It returns true if at least one of the elements in the array passes a particular condition, and false otherwise. One of the most versatile built-in methods for arrays in JavaScript is the filter method. This method is designed to go through an array and extract elements that meet a specific condition, returning a new array comprised of only those elements. It's particularly useful for creating subsets of an array that match certain criteria. So consider an array of numbers. If I instantiate const numbers, assigned to 1, 2, 3, 4, 5, and 6. If we want to filter the array so that we only have the even numbers, we can use the filter method. So I can say const even numbers, assigned to numbers.filter. So the filter method works by accepting a callback function, and this function acts as a test, often called a predicate function, that returns a Boolean value, so it returns true or false. For each element in the original array, the filter method calls this callback function, and if the callback function returns true for an element, that element is included in the new array returned by filter. If false, the element is excluded. So I will specify my callback function to be number, and I'll use the arrow function syntax. So number mod 2 equal to 0. So if this is true, then we know that the value is even. It will be included in even numbers. So let's console log that. Console.log even numbers. Then run in the panel. So here I see the array consists of only the even values. So let's look at a more complex example involving an array of objects, which is a more common use case for real-world projects. Throw this out, and I'll instantiate an array containing objects. So I'll say const employees assigned to the array. Then I'll specify the object. ID of 1, the name of Alice, and the role of a developer, comma, and then shift option and down arrow to create more copies. I'll update the IDs, and the names. I'll say Bob, I'll say Charlie, and I'll say Danielle. Update the roles, so designer, developer, and manager. So now I want to filter so that we only contain the developers. So I'll say developers equals employees.filter. Then I'll specify my callback function. I'll name it employee for the element. And then when the employee.role is equal to developer, then it will be included in the developers array. I'll output this, developers. And then when we run in the panel, here I see both employees with the role of developer are included. This demonstrates the filter method's power to work with arrays containing objects and utilizing the object's properties to make very specific selections. So the filter method is non-destructive and it does not change the original array. Instead, it creates a new array with elements that pass that test or that match the criteria. How would you filter the elements of an array? You would use the built-in filter method and specify a callback function. In that callback function, you would specify what condition you want to be true in order for that element to be included in the array to return. The map method is a cornerstone of array manipulation in JavaScript, offering a powerful way to process and transform array elements. It operates on each element of an array, applying a function you specify, and returns a new array composed of the results. This makes map an ideal tool for transforming data without altering the original array. Imagine map as a transformative method. You give it an array and a transformation rule, and it gives back a new array where each element has been changed according to that rule. Let's start with a simple example, squaring each number in an array of numbers. So if I initialize const numbers, assign to 2, 4, 6, 8, and 10. Using the map method, I will store the result in squared numbers, assign to numbers.map. I'll specify my callback function. I'll say num, the arrow function, num times num. In this case, map takes each number, squares it, and includes the result in the new array. Here if I log it out, console.log, square numbers, opening up the panel, we'll run this file. And here I see each value has been squared. Let's consider another example, transforming strings. So I'll delete this. So map is not limited to numbers, it works with any data type. So for this example, we will convert an array of characters into uppercase characters. So let's say const characters, assign to A, B, C, and D. I'll store the result in uppercase characters. That's equal to characters.map. For the callback function, I'll specify the element to be character, map to character.toUppercase, ending with a semicolon. So now console.log it, console.log uppercase characters. Then I run in the panel. So here I see each element has been converted to uppercase. I'll clear this out. So now I'll show an example working with objects. So when using the map method with objects, this enables us to update properties or transform objects entirely. For instance, if you have an array of employee objects and you need to normalize their email address to lowercase for consistent database storage, map makes this task easy to do. So if I initialize const employees to an array, and I'll say ID is 1, name is Alice, and email is mixed case, so I'll say alice@gmail.com. Just in case their email was entered in mixed case. I'll make 2 more copies and update the IDs and the names. So here I'll say Stephen, and I'll say Joe. And for the email, I'll just say in mixed case, and Joe. Ending with the semicolon. So now performing the map, I'll say const updated employees, assigned to employees.map. I'll name the parameter to be employee, an arrow function, and here I'll do a parentheses and then curly brace. So the curly brace is for the object literal that I'll be returning. So I'll use the spread operator, employee. So the spread operator copies over all of the properties into this new object that we are returning. Now I want to update the email property such that all lowercase. So I can do email, colon, and then I'll do employee.email.toLowercase. So in this example, map iterates over each employee object, creating a new object that preserves the original properties while transforming the email property to lowercase. The use of the spread operator ensures that we're not modifying the original objects, showcasing the map's utility in creating modified copies of objects while leaving the original array untouched. So let's console log that. Console.log of updated employees. Open up the panel, up arrow, and we'll run it. And here we see update employees, shows all the emails in lowercase. How would you transform or map over each element of an array? You can use the built-in map method. With that method, you would specify a callback function where you will operate on each element and transform it in some way. This would result in creating a new array consisting of those updated values. JavaScript has a very powerful array method called reduce. It can transform an array into just about anything, whether that be a single number, a string, an object, or even another array. Let's see how this works with a practical example. Let's consider an array of numbers, and we want to calculate their sum. Here's how you would traditionally implement it. If I instantiate const numbers and assign to 1, 10, 5, and 14, then I can initialize the sum and set it to 0. Then I can use the for of loop to iterate through all the elements in this array. So I can say for const num of numbers, then I can do sum plus equals num. Now I can console log that, console.log. Our template string, I'll say total sum, colon, using interpolation, say the sum, end it with a semicolon, and let's run it in the panel. Here I see the total sum is 30. Now this approach calculates the sum, but JavaScript offers a cleaner way to achieve the same result using the reduce method. So I can comment this out. The reduce method iterates over each element in the array, applying a function that you define and accumulates the results into a single value. Here's how you can use the reduce method to sum an array of numbers. So on a new line, I'll say const sum is assigned to numbers.reduce, then specify two parameters, the accumulator and the current value. Using the arrow function syntax, ending it with the semicolon, then I will return the accumulator plus the current value. So the first argument that we specify for the reduce method is this callback function. It also accepts a second optional argument, which is the initial value of the accumulator. So I'll set that to be 0 as the initial starting value. So a reducer function is called for each element in the array. This function receives two parameters, the accumulator, which is the accumulated result of the previous function calls, and the current value, which is the current array element being processed. The initial value for the accumulator, in our case, is 0 because we're summing the numbers, starting from 0. The reducer function's job is to combine the accumulator and the current value in some way, then return the result, which becomes the accumulator value for the next iteration. Once reduce has processed every element in the array, it returns the final accumulator value. Providing an initial value is optional. If you don't include it, reduce will use the first element of the array as the initial accumulator value and start iterating from the second element. However, it's a good practice to always specify the initial value to avoid unexpected results, especially when working with empty arrays or arrays containing elements of different types. So I'll copy this console log and output it just to ensure that we get the same value. I run in the panel, we get the sum of 30. So I can comment this out. And here is a simplified version of the sum calculation without explicitly providing an initial value. So I can do const sum is assigned to numbers.reduce, specifying the accumulator as the first parameter, then the current value, arrow function syntax, and then the accumulator plus the current value, ending it with a semicolon. Now I can run in the panel, and we get the same result. What is the reduce method and how does it work? The reduce method is a built-in method for the array data structure that reduces all the elements of an array into a single value. This value could be a number, a string, an object, or another array. It accepts two possible parameters. So for the first parameter, you would specify a callback function. This callback function will accept two parameters, the accumulator and the current value. Now reduce also accepts an optional second parameter. You can supply the initial starting value for the accumulator. Functions are the cornerstone of JavaScript, serving as reusable code blocks. In JavaScript, functions are objects. Let's explore two primary methods to create functions in JavaScript through function declaration syntax and function expression syntax. I'll rename my file to functions. Starting with function declarations, here we utilize the function keyword. A key characteristic of function declarations is their simplicity and the absence of a semicolon at the end. For example, we do function say hi, parentheses, and then console.log, hi. Then I can invoke it, just say hi. Let's run it in the panel. I'll say node functions.js, and here I see executed the statement within the code block. So this syntax is straightforward and efficient for defining functions. Now we also have function expressions, which introduce a different approach. I'll close the panel, and I'll delete this. So now implement it with function expression syntax. I'll say let say hi is assigned to function. Then our curly braces, I'll say console.log of hi. And I'll end the curly braces with the semicolon. So in this case, we define an anonymous function, which does not have an associated name, and we assign it to a variable, say hi. Note that functions are objects in JavaScript. So now I can invoke it, say hi, running in the panel, and we get the same result. So if I close this, so function expressions could also be named. So rather than using an anonymous function, let's say if I were to change the name of this variable to greeting, and I make this a name function, I can call it say hi, and to invoke it, I'll just use greeting, and then the parentheses. So this provides the flexibility of an expression and the clarity of a name function. So in this scenario, greeting acts as a reference to our function, treating it as an object. Then to execute this function, we simply invoke greeting. Here I'll just output it again, and we get the same result. In summary, JavaScript functions, whether using function declaration syntax or function expression syntax, form the building blocks of our applications. What are function declarations? Function declarations are the traditional syntax to create functions in JavaScript. You would use the function keyword and then name the function, specifying a parameter list, and then the implementation within curly braces. What are function expressions? Function expressions are an alternative syntax in JavaScript where you would implement a function, whether it be an anonymous function or a name function, and assign it to a variable. We can do this in JavaScript since functions are objects. In the previous lesson, we covered two different ways for creating functions in JavaScript, the function declaration syntax and the function expression syntax. A key difference between these lies in their behavior related to hoisting. To illustrate this, let's consider function declaration first. So implement a function, call it add, and it will accept two parameters, num1 and num2, curly braces, and we'll just console log the output. Console.log num1 plus num2. Now to invoke it, I'll just do add, then I'll do 2 plus 2, and let's output that. So we see the output is 4. Now with this approach, using the function declaration syntax, JavaScript allows us to call or invoke the function before it's defined in the code. So rather than invoking it after its declaration, I can move it before its declaration, and this approach would still work. So if I output it, we get the same result. This is due to a JavaScript mechanism known as hoisting. Hoisting is a process where the JavaScript engine automatically moves all function declarations to the top of their scope before code execution. This means that no matter where functions are declared, they are moved to the top of their enclosing scope, allowing them to be called before they're defined in the program. However, this doesn't apply to function expressions. So if I try this with the function expression syntax, closing the panel, I'll comment this out. So if I do let add is assigned to the anonymous function with the same parameter list, num1 and num2, and I'll just copy and paste this console log. Now if I try running it, clear this, and run it, this code results in a reference error because we cannot access and invoke add before its initialization. The reason is that function expressions are not hoisted in the same way as function declarations. Since add is defined using a let variable assignment, it cannot be accessed until the execution reaches the point where it is defined. In summary, hoisting allows function declarations to be lifted to the top of their scope, making them available throughout their enclosing scope. What is hoisting? Function hoisting refers to a JavaScript mechanism where function declarations are moved to the top of their containing scope during the compilation phase. This allows you to call or invoke the function anywhere within its enclosing scope. Let's dive into how functions handle arguments in JavaScript using a simple example. Here if I implement function, I'll name it multiply. It will accept two parameters, num1 and num2, curly braces, and then we'll just return the product. So num1 times num2. Now if I invoke it, console.log, multiply, and then 2 times 2, add in semicolon, so we can output it. So we get the output of 4. So when we call this function, we supply two arguments, and each parameter is assigned to one of these arguments, leading to the expected multiplication result. But if we were to call this and only pass one argument, for example, if I remove this second argument, and I call it again, I get the value of not a number. In this case, since we didn't supply two arguments, and didn't supply an argument for the parameter num2, then num2 will be assigned the value of undefined by default. So in JavaScript, any parameter that doesn't receive an explicit argument is automatically assigned to the value undefined. This default behavior ensures that functions don't break even when they receive fewer arguments than expected, though it may lead to unexpected results in your functions. JavaScript functions are quite flexible with the number of arguments you pass to them. You can even pass more arguments than there are parameters defined. So for example, if I would pass in 2, and then say if I pass in the value 4, if I were to call it again, here I get the expected result without an error. Now to actually make use of all these arguments, we can leverage the arguments object. Every function in JavaScript has access to a special object named arguments, which captures all the arguments passed to the function. So let's see an example of that. Here if I just console log the arguments object, arguments, opening up the panel, we'll clear this, then we'll log it again. So here I see this outputs the arguments object. In this object, the keys refer to the index position of the parameter and its corresponding argument value. If we want our function to support any number of arguments, we can iterate over the arguments object. If I close the panel, I will delete our statements in the code block. Then I'll declare let product assign to 1. Then I'll utilize our for of loop. So for, I'll say const num of arguments, and within it, I'll do product times equal the num. Then I will return the product. So with this setup, our multiply function can now handle 2, 3, or even 10 arguments, multiplying them all together. The arguments object is iterable, allowing us to loop over it with the for of syntax. It's important to note that while arguments is array-like, it's not a natural array. This means that it has some array behaviors, like being iterable and having a length property, but lacks array methods, like map or reduce. Here I'll clear the panel, and just log it out. And here I see the result of multiplying 2 times 2 times 4. By understanding the arguments object, you can create more flexible functions in JavaScript capable of handling a variable number of arguments seamlessly. Note that we don't often use the arguments object, but I wanted to cover it so that you're aware of it. What happens if a function is called with fewer arguments than it expects to receive? If a function is called with fewer arguments than it expects, then the parameters that you didn't supply a value to will be assigned the value of undefined by default. This could lead to unexpected results in your functions. Previously, we covered the spread operator, which is used for cloning objects in JavaScript. For example, if I create the object literal, let course assign to the object with the name JavaScript for beginners. I'll say duration 3 hours, end it with a semicolon. Now I can make a copy of this. Let's say if I do let new course assign to object literal, then the spread operator with 3 dots, and then the object that I want to copy. So if I log this out, new course, opening up the panel and running it, this outputs a copy of this object. So the spread operator allows us to easily copy properties from one object to another. Now if we want to modify the name property in the process, we could do so by put this on a new line, comma, and then I'll do name, and I'll change the name to be JavaScript Pro for the name of the course. I'll just add a spacing here. Now if I go to the panel and I run it again, here I see the name property has been updated. So now let's pivot to a similar but distinct use of this syntax in the context of functions. So when we use this ... operator, functions, we refer to it as the rest operator. So unlike the spread operator, which expands an array or object, the rest operator allows us to gather a varying number of arguments into a single array parameter. This is particularly useful when we want a function to accept an indefinite number of arguments. So I'll clear this out. So consider this example. If I declare a function, I'll name it multiply. Then for its parameter, I can do ... args. Specify the code block. I'll say return args.reduce. So this name of args is arbitrary. I can name it whatever I want. So this allows me to specify a varying number of arguments, which we packed into an array. So I can use the array method reduce in order to reduce all the values in the array to a single value. So in this case, it will result in the product of multiplying all these numbers together. So I can do accumulator and then current value, the arrow function. I'll close the sidebar so I have more room. Then I would do accumulator times current value. Then I'll specify the value of 1 as the starting value for the accumulator. So now I'll put this console.log of multiply 1, 2, 3, and 4. So I'll run in the panel. And here I get the value of 24, because it's multiplying these arguments together. So this shows an example of how we can use the rest operator in our parameter list. So I'll clear this out, close the panel. Let's consider another example. Let's say if I create a function, I call it multiply again. Now for the first parameter, I'll specify that to be multiplier. And for the second parameter, I'll specify that with the rest operator, and I'll name that array numbers. So then I'll specify return numbers.map. In my callback, I'll specify number, then number times multiplier, ending it with a semicolon. So this numbers parameter will gather any additional arguments passed into the function and store it in an array called numbers. So if I were to use this, I can say console.log multiply. So for the first argument, which we use as the multiplier, let's say if I specify 2, then any subsequent value will be an element in the array numbers. So I can do 1, 2, 3, and 4, ending with a semicolon. Now since I'm using the map function, this will return a new array with these values being doubled. So if I output that, I get 2, 4, 6, and 8. So this demonstrates how the rest operator enables the multiply function to accept any number of arguments beyond the first multiplier parameter. It's important to remember that if a function includes multiple parameters, the rest parameter must be the last one in the parameter list, ensuring it captures all remaining arguments. Also, the name of the rest parameter can be anything, whether it be numbers, args, or any identifier that makes sense in your function's context. What is the rest operator? The rest operator allows you to represent an indefinite number of arguments as an array. This is useful when working with functions that can accept a variable number of arguments. Let's explore default parameters in JavaScript, a feature that significantly enhances function flexibility. Let's start with a simple function. If I use the function declaration syntax, I'll say function, write code, and for the parameter, I'll specify that to be language, or curly braces, and then I'll console log with backticks. I'll say write code in, and then interpolation, language, end it with a semicolon, and now I can invoke it. So if I say write code, for the argument, I'll specify that to be JavaScript. I'll run the panel. So here we see a log to the console. Now, let's say if I copy this, Shift Option and down arrow, and let's say if I do C# as the programming language, run it again. So we implemented a reusable function. But what if we were to call write code without any arguments? Say if I do Shift Option down arrow again to copy it, but I don't pass any arguments, I'll clear this. If I run it again, here I see the last one is write code in undefined. So without an argument, this parameter is assigned the value of undefined by default. So this is where default parameters may be used. In modern JavaScript, we can assign a default value to parameters, ensuring our function behaves predictably even when specific arguments aren't provided. So here where I specify my parameter, I can assign it a default value. In this case, I'll say JavaScript. So I'll clear this, and if I run it again, here I see the last output was write code in JavaScript, since language has the default value assigned to JavaScript. So let's clear this, and let's do another example. So now consider a function with more than one parameter. So I'll say function code details. For the first parameter, I'll use language, and I'll have the default value of JavaScript. I'll close the sidebar with Command and B, and I'll do tool is VS Code, our curly braces, and now I'll console log, backticks, writing code in language using tool, end it with the semicolon. So if you set a default value for a parameter, then any parameters that follow should also have default values. This function has two parameters, language and tool, both with default values. So this design allows for versatile function calls. So if I were to call it with no arguments, I'll do another example, specifying just one argument. Let's say if I do Python, then I'll specify C# as the language, and Visual Studio as the tool. So if I output this and run it, here I see for the first function call with no arguments passed, it uses the default values. So writing code in JavaScript using VS Code. The second one, I just supplied one argument. So it's writing code in Python using VS Code. And the third one, I supplied two arguments. This outputted writing code in C# using Visual Studio. Let's do one more example. Let's say if I do function create user, the first parameter will be name. The second parameter will be role with the default value of guest. The third parameter will be status and assigned to active. Do my curly braces, and then I'll console log it with backticks, user, colon, then the name, comma, the role, and the status, ending with a semicolon. So now I can do create user, and I'll specify the first argument since this parameter is mandatory. So I'll say Stephen. And I'll do another example. Let's say if I specify the name to be Alice with the role of admin and the status is active. Here if I output it. So for this function, the role and the status parameters have default values. So this setup is practical for situations when you might not have all the details up front, but still need to ensure your functions executes smoothly. Default parameters simplify function calls and make your JavaScript code more readable and maintainable, especially when dealing with multiple parameters and the potential for missing arguments. What are default parameters? Default parameters allow functions to have predefined values that are used if no argument is passed to the function. Let's dive into the use of getters and setters within JavaScript objects, which enhance how we interact with object properties. So let's define a simple object. I'll name it const course assigned to, where the name is JavaScript for beginners, and the duration is 3 hours. We'll end it with a semicolon, and we'll just console log it. With backticks, say course.name is course.duration. So we output that. So we see JavaScript for beginners is 3 hours. So this basic approach allows us to access object properties directly. However, modern JavaScript offers more sophisticated mechanisms to interact with properties, such as with methods. So if I close this, so I'll specify a method in my object. I'll name it details, and I'll say return backticks. I'll say this, as in this current object, dot name is this dot duration, ending with a semicolon. So I can comment this out. I can instead do console.log of course.details for calling that method. So if I run this again, I'll get the same output. So while this details method effectively encapsulates the way we describe a course, it's read-only, so we can't directly modify the course details using this method. So this is where getters and setters can come in. So these special methods allow us to define custom logic for reading and writing properties. They're defined using the get and set keywords and are used as if they were regular properties. So to turn this method into a getter, I would use the keyword get before the method name. So to specify a setter, I'll do comma, and I'll say set details for the parameter, that'll be a value. So with this allows us to use this method as if it were a property of the JavaScript object. So this setter can be used to be assigned to a value like JavaScript for beginners is 3 hours. So if a value were to hold this string, we would need to break it up and store it in our properties. So I can say let parts is assigned to a value, calling the split method, which exists for strings. Then I'll specify the separator as the space is and then another space. So that will break this string up into an array, and I can access the elements of the array to update these properties. So I can say this.name is assigned to parts at the first index. Then I can say this.duration is assigned to parts at the second index, at the index of 1. I'll clear this out. So since this is a getter, it will act as if it is a property rather than a method. So in order to call this, I won't need to use the parentheses. So I'll put that, and when I run it, I get the same result. Now if I were to use the setter, which is this method we defined here, I can say course.details is assigned to, I'll say JavaScript Pro is 10 hours. Now if I were to access the details of this course, I can copy this, paste it here, and I'll comment this out. So let's run it again. So here I see my properties have been updated. And so when I call details, this outputs JavaScript Pro is 10 hours. So in this enhanced example, the getter for details simply formats and returns the course information, and we're able to access it as if it were a property rather than a method. Now the setter for details takes a string, splits it, and updates both the name and duration of the course object. It allows us to modify the course's details in a controlled manner. Getters and setters provide a powerful way to create virtual properties that you can read and set like standard properties, but with additional logic behind them. This feature is especially useful for validation, logging, and dynamically computed properties. Remember, while getters and setters make your objects more robust and encapsulated, they also introduce a layer of abstraction that can make debugging more challenging if not used carefully. What are the get and set keywords? The get and set keywords can be used within object literals or classes in order to define getters and setters. This enables you to use a method as if it were a property. The benefit of using getters and setters is that it can improve data encapsulation and provide a more intuitive interface for interacting with an object's properties. In this lesson, we'll explore the powerful concept of error handling in JavaScript, particularly through the use of try-catch blocks. So let's consider an object, course, with a getter and setter for its details property. Now for this parameter variable that we specify for our setter, there's no guarantee that this value is a string data type. For example, someone could do course.details and assign it to a number, for example. So we want to check and ensure that this parameter is a string. So I can check if type of value is not equal to a string, then in this case, we can just return and stop execution. Now, while this code will prevent the error being thrown, there are cases when you want to throw an error. In programming, we would call this throwing an exception. So here I'll do curly braces, and instead I'll do throw new error, and I'll specify the message to be value, and the value is not a string. So now the programmer who is utilizing this setter will now get an exception, an error, saying that the value they assign it to is not a string. So now if I run this with node functions.js, and it throws this exception. So by implementing this check in our setter, we can throw an exception when the value isn't a string, thus preventing unexpected behavior. However, simply throwing an error halts our program's execution and reports the error, which isn't always the desired outcome. So in JavaScript, errors are objects, and when thrown, they create exceptions. Now we don't want unhandled exceptions to terminate our program abruptly. So this is where try-catch blocks come into play, allowing us to gracefully handle errors. So I'll close the panel. Here, when we perform this operation, I can wrap it in try-catch blocks. So I'll do the try keyword, curly braces, and I'll move this code within this block. So within this code block, we would place statements that could potentially throw an exception. Now if an exception is thrown, then we want to catch it. I can name this E for error, or E for exception. So this will allow us to catch the exception without terminating our program. So we can output console.log a descriptive error message. So I can say caught an error. And here I'll just say e.message, which is a property that exists for errors. So now if I run it, run the panel. So here I see this outputted, this error message, rather than terminating the program. So to reiterate, the catch block specified here catches the thrown error, enabling us to handle it and log it to the console without stopping the program. So this pattern of defensive programming, particularly the use of try-catch blocks, is crucial for creating robust JavaScript applications. It allows us to manage errors effectively, ensuring our programs can recover from unexpected situations gracefully. What are try-catch blocks? Try-catch blocks are used for defensive programming, in the case when you are executing code that may throw an exception. This enables you to catch the exception in order to prevent your program from crashing. Let's cover the concepts of local scope versus global scope in JavaScript. First, let's discuss the global scope. So a variable declared outside any function, block, or conditional has a global scope, meaning it's accessible from any part of the code after its declaration. So if I just do const name is assigned to Stephen, and just console log it, the name, we output it, and we get our expected string. So here this variable is declared in the global scope. It's within global reach, meaning any script or function can access it. Conversely, local scope refers to variables declared within a block, function, or conditional. So these variables are only accessible within the confines of their curly braces. So if I were to instead wrap this in a curly brace to define a block, I'll highlight this and do command, then the right square bracket to indent it. Now if I run again, I get the same result. However, if I were to move this console log statement outside of the code block, and if I were to run it again, I get a reference error saying that the name is not defined. So since we declared this variable within this code block, it only exists and is accessible within the block it's defined in, and outside of it is not accessible, leading to a reference error. So the scope of a variable determines its accessibility. So declaring variables locally within a specific context, rather than globally, is generally considered best practice for several reasons. One is for avoiding global pollution. Global variables can lead to conflicts, especially in large applications or when integrating with third-party libraries. Another reason is maintaining code clarity. Local variables ensure data is only accessible where it's needed, making the code easier to understand and debug. Another reason is enhancing performance. JavaScript engines can optimize the lookup time for local variables better than for global variables. To further illustrate, let's see how this works within a function. I'll clear this out, and I'll close the panel. So if I name a function, I'll call it greet, and within it, I'll say const message is assigned to hello world, and then I'll console log this message. Now when I invoke greet, I'll get the expected console log statement. However, if I were to try to access this variable message, say if I do console.log of message, and then I run it, here I see another reference error saying that the message variable is not defined. So this shows that this variable is local to the greet function. It's created when the greet function is invoked and ceases to exist after the function completes, keeping our global namespace clean and our code predictable. Understanding the distinction between local and global scope is fundamental in JavaScript. It helps in structuring your code more effectively, preventing accidental data modification, and keeping your global namespace uncluttered. Always aim to minimize the use of global variables and leverage local scope whenever possible for more maintainable and error-free code. What is the difference between the global scope and the local scope? In JavaScript, the scope of a variable determines where it can be accessed within the code. Variables declared outside any function or block are in the global scope, making them accessible throughout the entire script. In contrast, variables declared within a function or block, such as loops or conditional statements, are in local scope, meaning they are only accessible within that specific block. In this lesson, I will discuss the differences between the let and var keywords in JavaScript, highlighting why modern practices favor the let and const keyword rather than the var keyword. In JavaScript versions prior to ES6, which stands for ECMAScript 2015, the var keyword was primarily used to declare variables. However, the introduction of ES6 brought significant improvements, including the addition of the let and const keywords for variable declarations. These were introduced to address some of the issues associated with the var keyword. So the var keyword is function scoped, meaning that it is only scoped to the function within which it is defined, not to any blocks within that function, like loops or conditionals. This can lead to unexpected behavior and errors in your code. So consider this example using the var keyword. If I were to create a function, I name it display, and if I were to implement a traditional for loop, I'll say for var I is assigned to 0, I is less than 5, I increments, and I'll console log that. So if I were also to console log outside of this for loop the value of I, so if I were to invoke it and run it in the panel, here I see within my for loop, this outputs the values of 0 to 4 and continues as long as the value of I is less than 5. However, I'm still able to access this variable outside of this code block, as seen in the outputting of the value of 5. So in this scenario, the variable I, which is declared inside a for loop, is accessible outside of the loop block, because var does not have block scope, but rather it is function scope. The let keyword, on the other hand, introduces block scoping to JavaScript. This means that a variable declared with let is only accessible within the block it was defined in. So if we update this to be the let keyword and run it, here I see what output every value in the loop. However, when I try to access this variable outside of the code block, then it would throw an exception saying that I is not defined. So to reiterate, in this version of display, attempting to access the variable I outside its defining scope, which is the for loop in this case, results in a reference error, showcasing that it's a block level scope. So why does this matter? We want to minimize the global scope pollution, and using let helps avoid adding unnecessary variables to the global scope, which could conflict with other scripts or third-party libraries. Using the let and const keyword also helps us reduce our errors. So block scoping makes it easier to track where variables are available, reducing the risk of accidentally overriding or misusing variables. It also helps improve code readability. So code that takes advantage of block scoping is often easier to read and understand, as it's clearer where each variable is defined. So while var has its place in JavaScript history, the introduction of the let and const keyword has provided developers with more robust tools for variable declaration. By understanding and utilizing the let and const keyword and their block scope nature, you can write cleaner, more reliable JavaScript code. What is the difference between the let keyword and the var keyword? Both the let keyword and the var keyword can be used to declare a variable. The let keyword is the modern way to declare a variable, and it was introduced in ES6. The difference is that the let keyword is block scoped and the var keyword is function scoped. With the let keyword, the variable will be accessible within the block it is defined in. With the var keyword, the variable will be accessible within the function it is defined in. In this lesson, we will cover the this keyword in JavaScript. Understanding the this keyword is crucial because it refers to the object that is currently executing the function or method. In JavaScript, the value of this depends on the context in which a function is called, not where it's declared. So let's break this down. If I create an object, name it course, with the name, JavaScript for beginners, and if I declare a method, I'll name it start console.log of this this.name. Now if I were to call this method, I'll say course.start. And if I output that, I get JavaScript for beginners. So in this example, the this keyword points to this course object, allowing us to access the name property of course. In a regular function, meaning not a method of an object, the this keyword will reference the global object. In browsers, it's the window object, and in Node.js, it's the global object. So if I were to remove this, and instead create a function, and call it start video, and here I'll just console log this. So I'll call this function, call start video, and I'll execute it. Scrolling up. So since I executed this with Node.js, this outputted the global object. And in browsers, this would output the window object. Let me clear this out. So that covers the function declaration syntax. Now arrow functions don't have their own this context. Instead, they inherit this from the parent scope at the time they are defined. So if I create another object, say const course assigned to the name, ES6, syntax, then start, and I'll have that use an arrow function, parentheses, the arrow, curly braces. This will console.log this.name. So now if I use that, course.start, when I invoke it, here I see this.name is undefined. This is because when using the arrow function, the this.keyword inherits from its parent scope. So in this case, from the global object. And since the global object doesn't have a name property, this value will be undefined. Now you can explicitly set the value of this using bind. So bind returns a new function with this bound to a specific object, but doesn't immediately invoke it. So if I were to clear this to demonstrate that, closing the panel. So if I were to create a function, and I'll name it introduce with the parameter of language, I'll do console.log, I'll say this.name, then using concatenation, say teaches language. So if I create an object, I'll say instructor assigned to my name. Now this function introduce has a bind method. So if I were to say const introduction is assigned to introduce.bind, then I'll pass in this object and with the semicolon. Then if I were to invoke it using introduction for the language, I'll specify that to be JavaScript, ending with a semicolon. And if I output it, here I see the string, Stephen teaches JavaScript. So performing the bind, this specifies this.name, which is binded to this object. So the this keyword in JavaScript plays a critical role in determining the context of function execution. Its value is determined by the execution context or explicitly bound using bind. Understanding and mastering this allows for more flexible and powerful code structures, especially when working with object-oriented JavaScript. How would you explicitly set the value of the this keyword for a function or method? In JavaScript, to explicitly set the value of the this keyword for a function, you can use the bind method. The bind method creates a new function that, when called, has its this keyword set to the provided value. This allows you to call a function with this set to a specific object, even if the function is defined in a different context. If you're interested in supporting my courses and projects, you can follow me on my new YouTube channel and Instagram at StephenCodecraft. And if you're looking to enhance your health and fitness routine, check out my workout and meal planning app at fitfuelplanner.com. The app offers over 100 recipes, workout plans, meal plans, and a grocery list feature. It's designed to make tracking your calories and macronutrients straightforward and stress-free. I appreciate your support.